Ok, já estou vendo live lá. So let's get started, people. Good afternoon. My name is Rodrigo. We are live on the LuxOUG Virtual Tech Days. We will have a full agenda with great names for Oracle community. So first of all, thank you for attending the event. Our group was founded in 2019. We already delivered 7 webinars. We have a total of 124 members on our portal. We have a lot of content about several topics like cloud, engineering systems, and a lot of good stuff. So if you are not subscribed on the LuxOUG, please do it. It's a completely free membership. If I haven't said enough, thank you, board member of LuxOUG, because we made it happen. We made the event go live today, and we will have a lot of fun this week. So I will give now the control to Tom Kupelars, will be our first speaker today. And this is us, LuxOUG members, the board member. André Ontalba, Carlos Magno, Fernando Simon, Leonardo Lopes, and me. So now, Tom, the control. I will stop my screen now, and you can share yours.
Okay.
Okay. So I will stop share.
Okay, let's start.
Yes.
Good afternoon, everybody, and welcome to this talk, which has the title Database Performance Core Principles. My name is Tom Kupelars. I work within the Real World Performance Group inside Oracle. Here's a little bit of myself for those of you who do not know me yet. I've been using Oracle for quite a long time, and my special areas of interest always has been application development, and especially database design and using SQL and PL SQL to its fullest. I'm therefore also a big fan of using the database as a processing engine, and I'll have some more to say about that at the end of this talk, and not just as a layer to persist data. Over a decade ago, I wrote a book, which you see on the right there, Applied Mathematics for Database Professionals. If you want to have some more information about what that book is about and whether it might be interesting for you, just drop me a message and I'll give you some more details on that book. But let's start with today's talk. Now, I always have a little bit of a dilemma when I do this talk. This is a talk that I've been giving in various forms and versions. So this is the latest version of this talk. And the dilemma is, I'm going to talk to you about database core performance principles. But it's probably not going to help you much immediately, because your applications will very likely need to be changed to comply with these performance principles. And obviously, in the real world, that often cannot be done, right? Because they need very likely re-architecting. So the dilemma here is that I will talk about it, but only to create awareness of this. And my hope then is that you can use the knowledge of this talk to influence future application development endeavors within your organization and maybe push them or nudge them a little bit towards a slightly different architecture that makes much better use of the computing resources that these applications use. Now, performance core principles, why do I want to talk about it? Because if you're in charge of your, or in any way involved in the performance of applications, you should be comfortable with questions that I have up here. If you have a single CPU, how many processes can be active at any one time? One, right? If you have 4 CPUs, can only be 4 processes active on 4 CPUs on 4 cores. What's the implication when there are more processes that want to run than there are CPUs? I'll talk about that. And what if my process needs to access an external resource, typically the network or an I/O? What happens to your process in the operating system? And what happens once that external resource request has finished? How does my process continue get back on CPU? And what's the difference between user and sys CPU? These are the kinds of questions that I think you should feel comfortable with, because they underpin the core performance principles that I will be talking about. So here's the overview of my talk. I will start with the fact that Oracle is a process-based architecture and the implications of such an architecture. That's the first bit of this talk. Then I'll touch upon these 3 concepts called response time, throughput, and database time. So then I've laid down all the knowledge, the principles that I think you should be aware of. And then I'll show, but along the way, I probably will have mentioned it also 1 or 2 times. I'll show that application development nowadays has fundamentally moved away from these core principles, which is why we see so many applications out there that either run or scale very badly or require a huge amount of computing resources to run satisfactorily. So let's start with the implications of Oracle being a process-based architecture. So what do I mean by a process-based architecture? Well, if you connect to the database, a process is forked, is started, whose sole purpose it is to service the database calls that you then can send to the database. Yeah? And typically in a modern application, you are not connecting anymore to the database. A connection pool will have done that, but the principles are the same. So the connection pool will have pre-spawned all these foreground processes on the database server who are there to receive database calls and then service those database calls. Now, for a process-based architecture, which Oracle is, to perform efficiently, a few things need to be in place. The operating system needs to be able to get the process on CPU as quickly as possible, because only when a process is on CPU can it do useful work for you. But then there's a second thing. Once a process is on the CPU, preferably you want to have that process stay on the CPU as long as possible for the duration of the database call. And that has 2 dimensions to it. One, the process should not go to sleep voluntarily a lot, and I'll explain what I mean by that. And the process should experience as few involuntary sleeps as possible. And I'll explain that also in the next few slides. So let's start with the first one. Here I have my foreground process, and it's currently idle. It's sleeping. It's not working on a database call. And here's my CPU. So now the application issues a database call. So what happens? The operating system basically receives an interrupt via the network interface card. Yeah? it sees a package arriving on a certain socket number. It then needs to figure out what's the process listening on this socket number. It finds that process and then asks the operating system scheduler to schedule to get that process on the CPU. Yeah? And once it's on the CPU, we, or the foreground process, can start working on the database call. Now, all work performed by the OS and the scheduler before the process is actually on the CPU is a little bit of sysCPU going on. It's operating system code being executed before the process actually hits the processor and can start doing useful work. Now, in order to get on CPU as fast as possible, there's this thing called current CPU utilization playing a role. Because on a CPU, there can only be one process active. A process is either on the CPU or it's off the CPU. You can't be 50% on the CPU. So at any point in time, when my process receives the interrupt and wants to do work, it needs to go to the CPU. And let's say if your CPU utilization is 50% current CPU utilization, then you have a 1 in 2 chance that the CPU is currently working for another process, is currently occupied by another process. Yeah, so then you have to wait a little bit in the runtime queue of the operating system before you can get your go on the process. Yeah, and this chance increases dramatically with the CPU utilization. Yeah? So if you have a CPU utilization of 80%, there's a chance of 1 in 5 that you actually get scheduled immediately, or 4 in 5 that you have to wait a little bit on the run queue. Now I'm showing this here just to bring over the concept, but I'm using a single core machine to explain this concept. It's of course less straightforward and a little bit more sophisticated with multiple cores. Now the CPU utilization, the current CPU utilization, does not only influence how fast your process can get on CPU. It also has influence on the overall duration of the database call. So it has a measurable impact on the response time of the database call, which becomes noticeable once you are, let's say, 60–70% busy rate or higher. And I'll show you that in the next graph here. So what I have here, again, I'm explaining this concept using a single core database server, is the formula for the response time. The response time of a database call is the service time, the time that it's actually required to do computation on the core, divided by 1 minus the utilization, the current utilization of the core. So let's say if your current utilization, which I have here on the x-axis, is 0%, you're the only one on the server, you get scheduled immediately and you can have all your work done immediately by this core. So let's say your service time is 1 second. Your response time will also be S divided by 1 minus 0 utilization will also be 1 second. But if your current utilization is 80%, your response time will be S 1 second divided by 0.2, 1 minus 0.8. So divided by a fifth, multiplied by 5, your response time will be 5 seconds. Yeah, so and the difference between what you actually wall clock time your database call is taking inside the operating system versus what it actually what it only requires to be done to be doing on the CPU, the difference is queue time. You're queuing and waiting for your go on the CPU again. Now every system starts queuing at some point. This again more complex with multiple cores, but even in multiple core database servers, at some point you will see queuing going on in the sense that processes can't be on the CPU all the time that they want to be on the CPU. This all depends on the arrival rate of your calls, the service times, the number of cores, and the current CPU busy rate. Yeah, but a significant time of the response time of a database call can be queuing time. That's one of the reasons why you never want your database server to be running at full capacity all the time or way beyond 70% busy all the time. So that's about getting on the CPU as fast as possible. The second thing that I mentioned in the introduction is you want to stay on the CPU. Once the process is on the CPU, you want it to stay on the CPU for as long as possible. I have a little animation here to show that also. Let's suppose you want to insert 10 rows. And there's two approaches. You can issue a single array-based or stored procedure call, which does all the 10 inserts, yeah? Or you can have an array-based insert where you bind 10 records into an array and you use the bind interface to issue a single insert statement, which will then insert 10 rows. Or you can choose to call the database 10 times, each time a single row database insert. Yeah. So on the right, I'm going on the core, I'm inserting those 10 rows. So I'm on the core a little bit, and on the left, I go on and off the core, on and off the core, on and off the core, 10 times. Two approaches of inserting 10 rows. So on the left, you have voluntarily chosen to sleep 10 times. That's what I mean, not go to sleep voluntarily a lot, because you've issued a call, you went on the CPU, you used a little bit of the CPU to process the one row insert, and then you chose to, and then your call was done. So you voluntarily, the process voluntarily goes to sleep again. And then it has to be scheduled again. Yeah, 10 voluntary sleeps, 10 schedules. On the right, you've only voluntarily went to sleep once after you've inserted the 10 rows in a single database call. Now there's also another thing going on, which is often overlooked and thought to be of negligible impact on the performance. And that is, for a process to go on the CPU, it has to, on the chip, you have to execute what's called a thread context switch. And a thread context switch is basically restoring your process's state on the core. Yeah, so all the values of the registers, the level 1, the level 2 caches, etc., they have to be flushed of the process that was just on the core prior to you going on the core, and have to be reinstated with your process's context. Now let's have a look at a thread context switch. That's microcode execution inside the core on the chip. So I have here a visual that I found on the internet, which shows all kinds of things that a core can do with increasing number of clock ticks that it takes for such a thing to do on the core. And this is a logarithmic scale. Yeah? So it takes one clock tick to do a register add or etc. to do a branch if or a floating point addition. Level 1 read, level 2 read, I'm getting into the 10 clock ticks now, level 2 read, etc., etc. C function direct call, maybe 50 clock ticks to do that, etc. Yeah, so it's these kinds of things where the Oracle kernel spends most of its time executing code in the SQL engine. It's all these kinds of instructions on the chip. Now, I don't know if you noticed this last one, but this last one is the thread context switch. That's the most expensive thing for a core to execute. Yeah. Over here it says 10,000 to 1,000,000 clock ticks. It depends on the core, but modern cores are probably more into the 10,000 clock ticks for a thread context switch to happen. And this has to happen. These 10,000 clock ticks are executing microcode that have to happen to get your process's context reinstantiated on the chip. Yeah, imagine in 10,000 clock ticks how much of these things you could have executed. Now on a 3 gigahertz core, this is 0.33 milliseconds, but we're not going to use that one. Let's use this one. On a 3 gigahertz core, this is still 3 microseconds, 10,000 clock ticks. 3 microseconds. Let's put that into perspective. A fetch by row ID inside the SQL execution engine takes, depending on how big the row is, etc., anywhere up to 10 microseconds. Yeah. So this is not negligible. I immediately get a knock-on of 30 to 50%. If I do a single row fetch or a single row insert is maybe a little bit more depending on the number of indexes that need to be maintained. But it's just to show you that it's not a number that you cannot ignore, especially if you choose to call the database many times, which is what modern applications do nowadays. But there's another thing going on. Yeah, so I mentioned 10 schedules, 10 context switches, and earlier I mentioned the network interface interrupt on the socket number, operating system entries and exits. But once my process is on the core, I'm not immediately inside the Oracle SQL engine. I have to descend the Oracle kernel into a few layers, get the message, unpack the message, and see what needs to be done, etc. So there's also 10 Oracle kernel entries and exits going on. And that too is not negligible. So like a thread context switch, it's measurable overhead. It's measurable if your calls are small and fast. If you're using a row by row approach, it's a thing that is actually measurable. We tested this using a lab environment. Let me give you just a summary of those results. So what we did is we created a simple batch process. We built it in Java, single-threaded, just keeping it simple, single-threaded batch Java process. In a tight loop, it would issue a mix of single row selects, single row inserts, and single row deletes. Yeah, all issued sequentially over JDBC to the database, generating 9,000 calls per second. So 9,000 calls per second and very easy, simple SQL statements, not taking a lot of time each in themselves. Then we used the Linux perf utility to profile the foreground process. And the perf is basically a utility which enables you to sample the foreground process. And what does it sample? It samples the current call stack that your process's execution is in. So we're sampling, let's say, 100 times per second, the Oracle server process, while it's working on these calls, 9,000 per second, to see where in the Oracle call stack we spend most of our time. And then using a Flamegraph, you can intuitively visualize that. So let's briefly talk about how to read a Flamegraph. So what I have here is a program that has a main entry point and then can call P1 or call P9. From P1, P2 can be called, from P2, P3 can be called, and P9 can also call P4. And we've sampled this program while it was running. And what we do is, in the Flamegraph generation, you sort all the code stacks, and vertically you see the call stacks, and horizontally is a representation of how many times that call stack was sampled, which ends up in the top surface being where all the time is spent relatively to each other. Yeah, so here you'd see we're spending most of the time in P2, especially if we take P3 into account with P2 also. Yeah, we're spending a lot of time in P9, a little bit in P4, and a little bit in P1 over here. Now let's show you the Flamegraph of that little experiment that we did. I'm just going to show you the big ones in here. So all over here, that's SQL execution engine code. You see a delete, an insert, and other stuff going on, fetches. This is all SQL execution engine code that has been sampled. But roughly a third of the time, we're spending time into these big mountains here. Yeah? So what's that? That's receive and send. So this is code that receives the database call, yeah? Where we actually have to read it from the socket in order to get it before we can look at it, interpret it, and start executing the SQL. And this is code sending results back. So with a fetch, we have to send a row back, or with an insert or an update, we have to send a return code back. Yeah, so this is writing into the socket back to the application server. That's a third of the time. A third of the time spent in user mode, just receiving and sending, getting in and out of the Oracle kernel. This is useful time. Yeah, so it's, again, this too is not negligible on a per call basis. Now, I can imagine you can't do flame graphs on your database server, but you can spot this phenomenon in an AWR report. You can spot and get an idea about the overhead of entering and exiting the Oracle kernel many times per second. So here I have a few snippets from an AWR where we're going to the database server almost 49,000 times a second. And the database server itself was fully CPU bound, working, so no major wait events. And if you look at time model statistics, you see this phenomenon where DB CPU is way higher than SQL execute elapsed time. Now, SQL execute elapsed time is CPU bound. Yeah? So this is all CPU. Why do we have a lot more DB CPU? Because over here it says 18,000 seconds spent executing SQL, but in total 28,000 CPU spent by all the foreground processes. That's the missing accounting of the entering and exiting the Oracle kernel. So what we spend here is not attributed to the SQL execution, but it is attributed to the foreground process usage of CPU. Yeah. So here we see 10,000 seconds, the difference between these two figures, of CPU spent on entry and exit, which is what you see on database servers that are servicing an application that does that. And all the application does is row by row approach, calling the database many times per second. Yeah, so that's a lot of CPU seconds that you're spending on basically stuff that needs to be done but does not add any value to your application. Executing SQL adds value to your application. You can actually spot the SQLs that are hit by this overhead the most. Again, under the assumption that you're CPU bound. If you can see SQLs that have where this percent CPU and percent IO do not nearly sum up to 100%, the last one, for instance, you see that this one is roughly hit by this overhead, almost, how do you call it? By a factor 2. And here we see 22% overhead. Here we see 13 or 12% overhead and another 12 or 11% overhead. Due to these selects very likely being primary key lookup selects and a fetch by row ID, which execute really fast in the SQL execution engine. Now, this overhead is not just on the database server. Every process has this overhead. What I'm showing here very quickly is the flame graph of the JVM of our lab test. So in the JVM, we also see these two flames in order to send out 9,000 times a second a SQL statement over JDBC across the network. Yeah, so here we also have a send and receive flame, taking roughly a third of all the CPU cycles that your JVM is burning on your application server. Useless stuff going on. Now, if you want to see the full story, I did a YouTube video on this experiment a few years ago. I have the YouTube video here, or you just go to YouTube and search for Koppelaars, my last name and database. And I think it's the top one. And then you can see the full report of this lab. Anyway, the status so far is that process architectures have measurable, notable per call overheads. Yeah, and I've mentioned so far the OS interrupt, figuring out which process to start. The scheduler needs to do its work to get the process on the CPU. Microcode execution needs to execute on chip to get your process state reinstated. And you need to enter the Oracle code before the SQL engine actually can start doing useful work. So the last thing about these core principles is a process should experience as few involuntary sleeps as possible. I have an animation again here. So let's say I now have 3 processes, and each process wants to do an insert of 10 rows in a smart way, an array-based insert or a call stir procedure, which does the 10 rows insert. And they all receive the database call at the same time. So what's going to happen? They get scheduled round robin based or whatever strategy is used by the operating system, but each in turn, because there can only be one process on the CPU at a time. That means that a process will get on CPU, it starts working on its 10 rows inserting, but it will get interrupted and asked to involuntarily go back to sleep while it wasn't done yet, for another process to be on the CPU and have some slice of the CPU. Yeah, so those are involuntary sleeps that processes can experience due to the fact that there are more processes that want to go on CPU. And you want to minimize those also, those involuntary sleeps, which basically means that in this particular situation, it would be far better to have one process insert 30 rows instead of having 3 processes at the same time compete for the one CPU and get those 30 rows inserted. Now, the number of processes per core that your architecture requires has an impact on the scalability of your architecture. Let's say I have an architecture where I roughly have 1 process per core. And with 1 process per core, with 4 processes and 4 cores, I can execute some number of transactions. As I scale up my architecture by introducing more processes and also more CPUs, I can get a relatively linear scalability. But this scalability becomes non-linear and quickly drops maybe to some steady state if your number of processes per core on average is way more than 1 per core. And there can even be a situation where you have so many processes per core that doesn't scale at all. And if you start adding more processes with more cores, the scalability actually decreases and your performance goes down. So those are the implications of the Oracle process-based architecture or any process-based architecture. Now let's spend a few minutes talking about user response time, throughput, and database time. So user response time, there are 2 important things to user response time. Of course, how long does it take for a certain use case to run before the user has a result of the execution of that use case? And the shorter that it takes, the better it is, of course. But you also want user response time to be consistent. Consistency of response time is equally important. The variance in response time is what's going to cause your users to start disliking the application. Let's talk a little bit more about that. So here I have two graphs depicting on the x-axis here the response time that a certain use case takes, and on the y-axis how many times that response time was actually experienced by an end user. So the red curve has a single spike, saying that the majority of all the response times were what? Between 1.5 and 3.5 seconds with an average of 2.5 seconds. Yeah, there are very few response times taking a lot more and very few taking a lot less. Now the blue multi-hump indicates we have variance going on in response times. And we also have a long tail. So we have experiences taking 7 seconds up to nearly 8 seconds. And you want the red curve. You do not want the blue curve. And I'll come back in a few slides on how to achieve within your architecture, how to increase the chances of you getting the red curve and not the blue curve. But let's first talk about throughput. Now, throughput is the number of units of work processed within a period of time. So how many of these use cases I can get serviced by my database server for a certain time period. It's something different than response time, obviously. But as the system gets busier, your throughput will increase, very likely. Hopefully in a linear way, if your number of processes per core is close to 1, which is good. But the response time for each individual unit will also increase. That had to do with the first graph that I was talking about. Because your throughput increases, your system is busier, so your CPU busy rate is higher. The chances of getting higher elapsed times, of course, your response time of a single execution will increase. So that means that if you've witnessed, let's say, a throughput of X transactions per second when your database server was 40% busy, that does not necessarily mean that when you drive your database server up to 80%, your throughput will be 2x. Very likely it will be less than 2x. The third concept, real short, database time versus response time. So here I'm showing you a use case of an end user behind an application that issues an application request, and the application request goes to the application server and it needs to do 2 database calls. So it goes to the database, back to the application, issues a second database call, and then the result is sent back to the end user. So the response time is broken down across all these different components. Yeah, the total user response time is the time spent on the network, the time spent in the application server, the time spent on the network between these two, and the time spent on the database server. Yeah, so a bit of gray, blue, red, gray, etc. So database time is just these 2 bits. Very often a very small component of the total response time that the end user experiences. Now, there's one point that I want to make also in this slide, and that is developers, when they look at the performance of the database, the developer, they will typically include this network time in what they call, it takes so and so many milliseconds for a database call to complete. Because from a developer's perspective, the database call starts here and it ends here. Whereas from the database perspective, it starts here and it ends here. Yeah. So the developer will typically add the network here to database time, or actually to how long it takes for a database call to complete, but it's not correct, of course. The other thing that I want to make here is we're now seeing customers move to the cloud, and sometimes they only move one of these to the cloud and the other one remains on premises. Imagine what's going to happen with this bit if you only move the application server to the cloud and you leave your database server on premises. Yeah, so this would be from going from sub-millisecond if these two are in the same on-premises database data center. And once this goes to the Frankfurt data center in our cloud, this suddenly becomes what, 3, 4, 5, maybe 6 milliseconds. Yeah? That has a huge impact on the performance of the application, because every database call would be increased by, let's say, 5 milliseconds additional here, 5 milliseconds additional here. Yeah, so your application server throughput will go down the drain if you only move one of these to the cloud and not both at the same time. So those were the 3 concepts that I also wanted to talk about: response time, throughput, database time. Response time, a single use case; throughput, how many use cases per second can I get through my system? And what's the database time component? Actually, only the red bits of those. 3 different things. Now, I wanted to come back to this graph. How can I ensure the red curve and not the blue curve for the end user experience? Because there's a core principle at play in this area also. Here's a different use case. And this time I'm calling the database 1, 2, 3, 4, 5 times. Yeah. So I have a breakdown like this, and I could tabularize it like this. I'm spending a little bit of time in the HTTP server, some time in the JVM, 6 times, some time in the foreground, 5 times for those 5 queries. The network outbound, I'm hitting only 2 times. And the network within the data center, I'm hitting 10 times. Those are these 10 little red lines here. Each time I hit the component, it has on average a certain duration. So I can sum up all those durations by multiplying the call count with the duration, and I get a total end user response time for my use case. Now, the way I'm showing this has a reason, because you get an idea that this is all linearly dependent on each other. And by that, I mean, let's say I have a use case that calls a certain component 20 times, which takes 2 seconds inside that component. The way this end user response time is built up makes you think that, let's say, if I re-implement that use case and it requires now 40 calls in that certain component, that you have a linear relationship. Yeah, because let's say if this if I go from 5 database calls to 10 database calls, and on average they have a certain duration, this 5 becomes a multiplier of 10. So it's a linear relationship, is what you think, but that's not the case. The actual relationship for each of these components is the more you call them for a certain use case in your application, the more likely your use case will be hit by queuing in that component. Yeah. So the higher the call count, the more greater the chance is that you will spend some time queuing, which you did not well in the prior call. But it's not just that this now starts deviating and going up, and taking more time on average. The variance also increases. Yeah. So in order to get the red single spike response time behavior, you want to minimize the call counts across components, across processes, because these are all separate processes. The JVM, the HTTP server, the foreground, and of course the network is also a component that you use and might spend some time queuing before your packet actually gets transmitted on the network. So the smaller the call count, the less likely you will be experiencing this variance, and therefore you get those single spike response times. So Oracle is a process-based architecture. To perform efficiently, you want to get on the CPU as fast as possible. You want to stay clear of those 100% busy times, also on your application server. It's better to call the database with more work in a call than to call it multiple times with little work. That's to do with the principle that processes shouldn't go to sleep voluntarily a lot. And you should use an architecture that requires a small number of processes. I'll have some more to say about this also in a minute. Yeah? And consistent response times require minimization of call counts across components. So if we see these kinds of things in AWR reports, we get an AWR report and we immediately see, okay, 23,000 calls per second, or maybe even 50,000 user calls into the database, which you can also see in the load profile. I personally like to look at this one first. And we see that every call is a very quick call, SQL engine requirement-wise, because they all execute a single row, which you can see in the SQL ordered by executions. So you're not wanting to stay on CPU long. And you have a 20-core server, and you have a factor 100x in terms of number of processes. So every core has 100 processes. So the OS scheduler does what it does best, descheduling processes all the time, making them experience involuntary sleeps. Here I have a situation where I almost have 150 processes per core on average. If we see these, we know that despite lots of CPU being burned, not much work is getting done, because the majority of the CPU time is spent on per call overheads. If we also see high busy rates, again, the response times probably aren't consistent. So one final topic. So I've talked about the core principles, core performance principles that you should be aware of if you're using a process-based architecture, which is what Oracle is. So what happened the last 2 decades with application development? Because it's my statement that it fundamentally moved away from these core principles. We stopped using the database as a processing engine, which is actually adhering to these principles. Let me explain that. So on a high level, an OLTP application can be viewed of, let's say, 3 major levels, 3 major layers. We have the interfaces, we have the business logic, the big chunk, the core of our application. And of course, we have the tables, the data store. And there are 2 fundamentally different architectures to build these applications. You can have all the business logic outside the database, inside Java, using layered software architectures, using frameworks, persistency frameworks, etc., inside a JVM, which have all these SQL generated and issued to the database. I sometimes refer to this as the no-pill SQL approach also. Or you can embrace all the business logic and have it run inside the DBMS, where you make heavy use of both SQL and pill SQL. Now, these two different architectures fundamentally deal also differently with the core principles that I talked about. Let's give you an example here. So here I have a use case where I'm depicting it in PL SQL code, but think of this being Java code. So we have some Java code and it selects a single row from orders to retrieve the limit. It then inspects the limit, and if it's more than 2000, it says, okay, well, I consider this a high risk order. I want to go across all the order lines, so it submits a second SQL statement and starts fetching these row by row, all the order lines of that order. Then per order line, we look whether it's open, and if the discount is more than 10, I'm going to decrease it by 10 because I consider this a high risk order. I want to decrease it by 10, otherwise I set it all the way down to 0. Once I've done that in my program variable, I'll bind that program variable again to an update statement to update the actual row in the database. Yeah? So we have bits of business logic going on outside the database, and then single row SQL statements. Now, if you look at this particular use case, it could actually be done in one single update statement. And that's what I mean by using SmartDB or using the database as a processing engine. I could update the order lines, set the discount, decrease it by 10, ensuring it doesn't become negative, of open orders who I consider, of open order lines who have a parent order that I consider to be of high risk. That's a single update statement. Yeah? We hardly see these kinds of statements anymore in modern applications. Yeah? It references more than one table, affects more than one row. Why don't we see this? Because all the SQL nowadays is generated for the developers. All these frameworks that they use inside the Java layer, they generate row by row SQL statements. They can't deal with these complex business logic containing SQL statements. Whereas in the situation where you have your business logic outside the database, you are calling the database multiple times. Yeah? I'm going to retrieve the order. I'm going to retrieve the order line, update the order line, retrieve the next order line, update the order line, retrieve, etc. Whereas here I send a single update statement. Yeah? So immediately you see that these new architectures, they call the database orders of magnitude more than a different architecture that's also there and available to you would require to call the database. So we have high call counts between processes. Fundamentally different architectures. All business logic outside the database implemented in these layered software architectures, whereas SmartDB using PL SQL and the database engine as a process engine, basically only the user interface sits outside the database. Oracle Apex Application Express is the prime example here. Many small calls to the database leading to a high rate of voluntary sleeps. Only one user experience is one database call, reducing voluntary sleeps. Noticeable per call overhead, as the call is a fast executing SQL statement. Here, of course, you also have the call overhead, but my call now does a substantial more amount of work. It wants to stay on CPU much longer, and the call overhead is, in terms of the work being done, not noticeable anymore. Of course, the number of times we hit this overhead has reduced an order of magnitude also. Now, I also make the statement here that these new software architectures require a large number of foreground processes. You probably have seen connection pools in your applications into the hundreds or maybe thousands of connections going into the database. Whereas these architectures require a very small amount of foreground processes. Now, I'm not going to explain that in this talk. There's too little time for that, but there's a YouTube movie on just this topic also. Again, if you go to YouTube, I did an Ask Tom session. You just search Ask Tom connection pool. The top one will give you a full hour talk on explaining why This approach requires a large number of foreground processes, and this approach does not require a large number of foreground processes. It basically has to do with the network time between the application server and the database server. That network time basically implies that the foreground process will not be busy during that time. So your architecture is not capable of loading foreground processes. It implies a certain percentage of idle time per process. And that then implies that you need more processes to get the database busy doing work. Yeah, so I talked about all this. Every SQL statement requires those 4 before it arrives at the SQL engine. So you have those fixed CPU overheads, and it could be a 2x knock-on. I think I also have a second AWR snapshot on the next slide. Again, I said this is not just on the database server where you have all these context switches and fixed overheads going on. It's also happening on your application server. Now, who's using microservices? Very likely some of you have applications that have been built using this, what used to be very popular microservices architecture. So here I have this use case again that calls the database 5 times. Let's say I'm going to add 2 microservices to it. There's a microservice here at the start, which calls out to a different JVM to check the balance, saying that this is a bank transaction. And it's a synchronous, or not, maybe not even, it needn't be synchronous. Let's say it's synchronous. So I go over there in a different application server to check the balance. I do my work, I do my transaction, and at the end, I'm also gonna call a microservice that audits my transaction. So stores audit information in a different audit database. Yeah. So if you have applications like this, not only do you have more components and risk a more variability in the end user experience times, of course, this whole architecture is rife with per call overheads. Yeah, you can have dozens of application servers burning lots of CPU, but not doing much useful work. Almost half of those CPU are per call overheads. So what I wanted to show you is this little snapshot here from an AWR report. This was an actual investigation that we did a few years ago, where we saw a database server being busy 50%. So that's not bad. 50% is a busy rate where you can get fairly quickly scheduled onto the database. But notice the number of sys CPU. You want this to be like a couple of percentage points, but here it's almost 1/3 of all the CPU being used. So the fact that you have a high percent sys already is an indicator, a red flag, probably indicating that you are calling the database a lot of times per second using small calls, 27,000 in this time. In this particular case, we also investigated the CPU used by the foreground process, and it turned out that half of these 32% was Oracle code entry and exit point, because the SQL statements were really small and really fast executing. Yeah, so I'm burning 50% of the CPU, but only 1/3 of that 50% is doing useful application work. The rest is all overhead. You're not using the database as it was designed to be used. That's the major issue here. If you want to reduce your computing resources, you should consider the other architecture. You should consider implementing much more logic inside smart set-based SQL and PL SQL using as the embedded programming language from which you submit all your SQL statements. And now my statement here is, if you have an application that's built like this, and you move it over to an architecture like this, I'm going to make a statement here, a bold statement. Your database will be less busy. It will be less busy. We've witnessed this. Why? Because the massive reduction in call counts gives you a great reduction in CPU used on your database server, both sys CPU and user CPU. The gains that you get from reducing the call counts by moving to the different architecture outweigh the business logic that you bring into the database. So the cycles that you free up easily enable you to implement business logic in the database. And you still have headroom. That's why I say your database will become less busy. I think seeing this is believing it. You might do simple tests yourself to figure this out yourself. So in summary, The majority of the current applications have large computing resources footprints because they were built using layered software architectures where all business logic execute on application servers, giving rise to high call counts per second. Yeah? And they thereby violate all database core performance principles. If you want to reduce your computing resources footprint, don't bring data to code, bring code to data. Yeah? Don't bring data to business logic in the JVM, bring business logic from the JVM into the database using Smart SQL and PL SQL. You need to focus on minimizing chattiness, process context switches, call counts, etc. You'll not only find that your database server becomes less busy, your application servers as well. The footprint over there will reduce greatly, and your user experiences will become more consistent. And with that, I would like to finish this talk today. If you have any questions, you can email me. You can also find me on Twitter. And Rodrigo, I don't know if there's questions. I think we have 5 minutes for questions. I'm not hearing anything.
Yes, Rodrigo is checking the questions. At the chat at my side, I have questions.
Okay. I was trying to find the button to unmute myself. So I don't see any questions. We have 5 minutes for questions. So people, you can do now the questions to Tom. And also, as he said, you can after send some by email if you wish. Okay, Tom, we have a question asking you to share the name of the book.
The name of the book.
Okay, let
me go here. Applied Mathematics for Database. So this is a book. Let me just make one comment about it, which focuses on this bit, database design. So beware. This is basically explaining the mathematics behind the relational model of data as it was invented by Ted Cott and evangelized by Chris Date during the 80s and 90s. So it gives you a mathematical background on how to design databases in a correct manner, adhering to the relational database theory.
We have one more question. How to convince the current developers focused on microservice to meet the best practices?
Yeah, it's extremely difficult to convince developers. My experience has been they can't be convinced. They know they are right. The only thing that I can show them and the only material that I confront them with is actual data. Show them AWR reports where you can see the evidence of the overhead. Show them, well, but that goes a little bit further. Show them profiling data of the various processes. Show them how much time their JVM is spending on useless work, sending JDBC statements out and receiving statements back. Yeah, because these developers, they will make claims. Well, I have 4 application servers, all 8 cores, and they are busy 80% of the time. No way this can run in the database. Well, the statement here is those application servers and all the CPU they burn, well, right off the top of the head, more than 50% is useless work. Then, let me just show you one more time, this flame graph of the JVM. And then I'll stop. So this is overhead. This is just JVM housekeeping. This is where the program was actually running. If you zoom in on here, you'll see the majority of the time is spent in JDBC layers. The majority is just going down and up JDBC layers. This is going in and out of the process. This is going up and down JDBC layers. If they're using frameworks, you'll see much more overhead here. And all that overhead disappears if you start using set-based SQL and PL SQL in a smart way inside the database. My statement here is if you're spending 100 seconds here, I can replace that by a single second inside the database by using the database the way it was designed to be. Yeah.
Perfect.
And with that, let's move on to the next speaker, right, Rodrigo?
Yeah.
Yes.
Okay.
Thank you so much, Tom, for your presentation, and thank you, the attendees, to being with us today. And we will go to the next speaker. Will be Pete. Pete. So, Fernando, it's on.
Yes. The next speaker will be Pete. He will speak about partitioning. After, we have Bruno that will speak about Python, and at the end, Harley we will speak about machine learning. So I will ask to Pete. Hi, Pete. If you can share your screen.
Yep, I can see you. You guys can see me. I'm alive and kicking and everything.
Yes, thank you so much.
This screen will stop. Yeah, continue. And I'm going to get my desktop in. It's almost like a real Zoom meeting. Can I?
Yes, we are here. We are seeing your.
I'm canceling my video, by the way, but
okay,
you guys know I'm here and, and I'm sitting.
No problem. At the end, we will advise you the remaining time and to open Q&A if you say. It's with you right now.
Okay. Yeah, you're allowed to interrupt me from time to time, but if it gets too much, I will just say help. You know, I am talking about partitioning, and this may look a little bit like the 1999s or something. Partitioning is fairly old, and like most of my presentations, it's based on a bit of a frustration I have with the developers or the architects who didn't or couldn't or abused the partitioning concept. About me, I ride a motorcycle. It's more or less a known item. So I would love to visit you guys, but Corona got in the way. My customer list, nah, fine. I have been wearing a mask about 10 years ago when I was in a factory in Singapore. But most of my time is spent drinking coffee. That's why the picture of the coffee cups is there. Connor told us that we shouldn't do agendas on virtual presentations, so I don't. I'll just talk about partitioning. If you want to get to your coffee quickly, my final slide will be, you better design it right. And skip to the last slides in about 55 minutes. My other top tip is always to please keep it simple. I will try to finish in time so we have a bit of time for, for question and answer and discussion. I'm actually quite curious to hear how many of you have made partitioning errors or booked a success with partitioning. So here we go. The basics. Why partitioning? It's very simple. A partition table is effectively split into many small pieces, many small tables. And that has a lot of it, that has some advantages, and some of the consequences can be can get into your way. So I'm telling you why I think it would be a good idea and why sometimes it is not. And I will try to demo that with some SQL. In my opinion, there are two main advantages. The first one is you will avoid redo. If you partition properly and use partitioning correctly, you can avoid redo in certain situations. And that's a benefit if your system is more or less redo constrained, if you have a data guard over a long line, that sort of thing. The less redo, the better. The less work, the better. Always. The other advantage of partitioning is if you apply it properly and design it correctly, you will scan less data on queries. So your queries become more efficient. You don't need all the other gizmo options, and you can deliver your results to the user a bit faster. And by the way, I have to thank Tone for putting the Smart DB out there. That's a different story. This one is just about efficient queries, but I fully support, bring your code to the data. But that's for another time. There are a lot of other advantages to partitioning, like you can compress partitions. You can use reads, you can use storage tiers, you go to read-only table spaces. You can use partial indexing. I think that's nifty. You can use ref partitions. I would love to try that in earnest at some point in time. You can use hybrid partition tables. I am so impressed with the capability. I would probably hesitate to use it because that is like, wow, but over-engineered. There is a lot, and if this goes well, I'll do a couple of more PowerPoints on partitioning. This presentation will be about the basics, hence back to basics. Oh, I should mention partitioning is one of the few things that's been in Oracle since about 1997. We had partition views way back. Partitioning, I think, is still a paid for option. That means that Oracle is probably capable of making profit out of it, and it's probably adding real value to a small group of highly paying customers. That is just my sort of gut feeling about it. A lot of other options have become free over time. Partitioning is still out there. Correct me if I'm wrong, put something in the chat, we'll discuss. So here we go. I will end by telling you that doing partition properly, you can avoid redo and you can scan your data more efficient. Let's do some basics. Here's a table, and the records in that table are spread all over. If it's a terabyte table, your records can be anywhere from the start to the end of that table. You have an index, and in the index, your, for example, primary keys are nicely ordered from low to high, and this is where you can search. The index is connected to the table, and there you are. Keep this image on your mind. We will come back to this. We will explain partitioning. We will explain indexing, searching. All of it comes down to this simple mental image of a table with data and an index with pointers. I would almost go, any questions on this? But that's a bit complicated on the thing. And this would be a partition table. The table is still there, but it's split into smaller pieces. I'm using 4 in my example, but a typical partitioning would be something like 1 per day for 7 years or so. You would have like 3,000 partitions. It's not uncommon. And in this particular drawing, I have local indexes. Every partition is paired with an index that is called local. So this local part of the index only contains pointers to that one particular partition. I have that way I get smaller pieces. So all my data is now in smaller pieces. Why? Well, for example, we know exactly what is in partition 1, because that, in this case, would contain the ranges from 0 to 10,000. So I know that if a record has a primary key below 10,000, it's probably here. The optimizer can use that sort of knowledge quite cleverly. It is still one table. For the queries, the application, and all the SQL is a single table. And the indexes in this case are local. Keep that in mind. I'll show you a global index in a moment. And the big advantage is local index part is connected to local partition, local table part. Any questions? Yeah, right. So there we go. This would be a global index. My table is still partitioned. My data is in known areas of the table, like everything between 3 and 4,000, 30 and 40,000 would be about here in this partition, but the index is no longer local. This becomes a global index. You could do that, for example, on a status field or active yes, no. All the N's would be at the start of the indexes, all the Y's would be at the alphabetical end of the index. And the pointers would point everywhere. So this global index is suddenly connected to everything. The consequences of that will be clear in a moment. So the first advantage of partitioning, remember, you just have to remember 2 things: less redo and better, more efficient query. So the less redo part, here we go. Every insert, update, and delete is work for the database. It generates undo and redo. And redo means archiving activity, means standby connectivity, means work. We don't want that. So someone says, oh, you know, on delete, truncate is really fast. Truncating a table or dropping a table is the fastest way to modify data, if you like, because it's a definition thing. doesn't require a lot of redo. You know, I'm not going to ask any questions about this, but most people probably know that drop or truncate is the fastest way to modify or mess up your data. So yes, with partitions, you can do that. So imagine dropping a partition, meaning you delete a large part of your data with very little effort. However, you've already understand it. You probably already begin to see you can only do that if your partitioning is suitably arranged, if you know where your data is, and that happens to be the particular data you want to delete. And it actually only works on delete or on something called exchange partition. So the use case for this, if you like, is limited. Keep that in mind as well. Now, how does that work, a drop partition? Well, you type the alter table drop partition at the semicolon, hit enter, and what's going to happen is it's gone. Not difficult. And so this effectively is a very fast operation. You can delete 1 million records with a single statement, and there is virtually no wait because there is no redo generated. The definition of that partition disappears from the database. Everything still works. Nobody has to wait. So what happens if you have a global index? Now remember, this thing is connected like spaghetti. So when I type my command in there, I drop my partition. There it goes. Yeah. That part of the index is pointing nowhere. This part of the index is pointing nowhere. Is that index still useful or usable? And in earlier partitioning versions of Oracle, we know this index becomes unusable. In the latest versions, there is an automatic process that tries to quickly repair the index. But in all cases, the index is unusable for a while, and it generates a lot of effort, a lot of redo. So a lot of my advantage has disappeared. And effectively, that whole index, global index, is unusable for a short or a longer period of time. And that is something I don't want. Now, you can even run into errors that say unusable index. I forgot the exact number, but some of your queries will suddenly fail. And it's not something you want to happen to the application. So demo time, I'll show you a table, a partition table, same data. We'll delete and see that generates redo. We'll delete from the partition table. That also generates redo. And then we do that magic drop partition, which is so much more efficient. There we go. And this is the exciting part, because I don't normally do demos a lot, but hey. So the demo is, of course, so easy. I just have to hit enter all the time, and I'm glancing at my watch. I'm fine. We create a table. We partition it by range, interval, so that it automatically expands, which is very useful. I'll get 4 demo partitions. I'll name them explicitly. If you use interval partitioning, your partition names will be something like sys something, and that makes it more difficult to drop them because you have to find the name. No big deal. Check the table, put some data in. I have to wait for the statistics to generate. That is actually the most time-consuming part of the demo, waiting for the stats to compilate. And there we go. Yes, I have a faster script for this, but if I don't calculate the statistics correctly, I get all sorts of weird behavior. I have one table with 40,000, and I have another partition table with 4 partitions in there. Remember, we're going to delete data. So what are we doing? We delete from T, we delete from PT, and then we drop a partition and we compare that. I would be tempted to ask, are there any questions? I'm monitoring the chat, so if anything really urgent, just put it in chat and I'll read it. There we go. I'm deleting from my table about 10,000 records. That generates 23 meg of redo. And I'm explicitly querying that from my statistics because some of the operations don't have an automatic statistics here. So I'm also checking it myself and the numbers correspond. Deleting these rows, 10,000 from a table generates about 23 meg of redo from a conventional table. Let's try the partition table. Where am I? This is always, there's the conventional table. Here's the partition table. I'm dropping the partition number 2. How much redo does that generate? Well, about 34 kilobytes of redo. I'm going to do the thing again because I hit enter once too much. Please excuse me. See, this is why you shouldn't do live demos ever, because something goes wrong. Creating my index, gathering my stats. And stay away from the enter key. This is where you want to see the audience to know if they haven't been falling asleep or getting coffee or walking out. Deleting my 10,000 rows. Here I'm deleting 10,000, 23 meg of redo. Now a lot of redo. You don't want that sort of redo, but you need it. Now I'm deleting data from the partition table. I delete the similar amount of rows from the partition table. I'm getting about 26 gig of redo. A lot of work. So deleting from a conventional table, partition table, both generate this redo. Now let's drop a partition. Alter table, drop a partition. And that is only 34 kilobytes of redo. That is about 1,000 of the total. Let's have a look. If I delete my 10K records, I get about 23,000 K of redo. From a partition table, I get about 26K. You're fine, let's wave. But if I remove my one partition, I generate 36K of redo. On a sizable system, if you're dropping gigabytes or even half terabytes of data, this is a big difference. And that's where partitioning comes in as something really efficient. So main point was, if you use that drop partition, you save on the redo effort. Your log writer saves effort, your archiving is less, your standby is easier. It just saves you effort and time. Now remember, I showed you that global index, and that was a bit of a problem. So of course there is a demo that shows why a global index is a bit of a problem. Same table, same statistics, same 5 seconds wait. This is where you sip your coffee. And we're back. We have the partition table, 4 partitions, 10,000 rows each. Let's get a global index on that. So what do? We drop a partition first with a global and then with a local index. Off you go. Creating a global index on PT, global index, and ready to drop. Everyone there? Everyone still awake? Okay. Alter table, drop partition, PT1. Whoops, my index is now unusable. And someone's going to raise a finger and say, oh, but this background process will fix that in a second. Right. In this particular case, I've had that background process fix it faster than I could query. But if you drop a gigabyte, if you drop half a terabyte, you know, that background process is going to have to work no matter how. So I'm not quite convinced about those background processes. I do appreciate they're there though. How much did we do with that? We have to rebuild the index. So I'm doing that explicitly, because if I don't do it explicitly, that redo statistically goes into the background and I can't measure it. So I'm rebuilding it, and that's about 200K. It's not too bad. That's still a lot less than the total, than deleting 10,000 rows, but rebuilding an index, so as soon as it becomes sizable, you will notice this, and it will take time. You know. So now let's do it with a local index. I'm dropping the global index. I'm creating a local index. Everyone see the blue stuff on my screen, of course. I've replaced my index. Let's drop a partition. And now I am in the situation where every part of an index corresponds to just one partition. So ideally, I can just drop it with a flip. And there we go. I've altered my table. I've dropped partition number 3. You know, partition 1 was already dropped. My index partitions are, the remaining 2 index partitions are still usable because they haven't been touched. Their data hasn't been dropped. Only the data for partition 3 was dropped. And the redo size for this is in the same order as about 34K. This is the data dictionary operation effectively needs redo. And that's all. This is extremely efficient. So what have we seen? We've seen a global index. We dropped the partition, the index became unusable, and it took me 200K of redo. I've seen a local index. I've dropped the partition. The index remained usable, and it only cost me 30K of redo. Now, question for you guys out there. What would happen if those partitions were terabyte sizes instead of just a couple of K? And, you know, answers could be given in the chat, but I think most of you will understand. The other question, and this you can Google if you like, which background process does the building of the indexes, and how long would that take approximately, and what would it depend on? And again, it is something we can discuss later at the informal point. The main point was, you know, if you use partitioning, you probably want to avoid global indexes. And I will immediately give Herman Beer, the partition product manager for Oracle, all the credit that is due. This guy is very intelligent, and we've had a couple of really good evenings discussing this. Yes, there are improvements in every version, and the improvements are really counting. I'm looking forward to Oracle 20, really. But for the moment, and basically always, if you drop a partition with a global index, you have to kick the redo. You have to process rebuild the index, and you have that redo coming at you. Back to PowerPoint. I'd be tempted to say, you know, any questions at this point in time? That was the first part of the demo. That went well. I'm still alive. My laptop didn't boot. So we've seen the drop partition. We've seen the efficiency on the redo. What was the other part again? Something about queries go faster. And faster queries mean you process less data. You have to do less work. Somehow you try to scan as little data as possible. You try to process less blocks, less IO, use less cache, become faster. Typical use case for partitions here is if you aggregate over a partition or a few partitions. And I'll show you in a moment. The anti-pattern for queries and partitioning, if you have to loop over all partitions, then suddenly it becomes a lot less efficient if you have 1 million partitions, because you end up with 1 million loops doing effort. And yes, you might be able to parallelize that, but that still means you consume a lot of resources and effort. So let me try and explain this. And this is going to be the slow part. I had my table with data all over it. I want to do something like a sum over a range. Let's say I want the sum of all number 2 records. That probably is going to be an FTS, like something like this. And maybe I don't want that if my data is really massively big. So partition table. And if we know where to look for our data, then maybe we can just scan one partition. And this is where your design comes in. You have to know your data, and you have to know and control your SQL. And then if you are lucky, and there are a surprising amount of use cases where you're lucky, if you're lucky, you just scan one partition, and it's about 1/4 of the effort, isn't it? Demo time. Let's do one of those sum queries. And demo part, there you go. Rebuilding my demo. And that's so, well, the demo rebuilds. So I'm going to query on a sum, and we will see where a partition makes the difference. I'm just rebuilding my data. I'm glancing at the other laptop all the time to see if there are any worries. No worries, we're good. I tried to do this with a single %, and then it upsets the cost-based optimizer. There is one big lesson of all the demos: always get your statistics, because the cost-based optimizer will try to outsmart you and do something stupid. So you have to wait for those statistics. Here's my partition table, 4 partitions. Let's go on the demo. This is the sum demo. So what do? We aggregate the data first on a table, then on a partition table, and normally we would see that doing just a single partition. Let's have a look. I got my select sum something. I'm doing a table access full on my conventional table, group by, etc. There we go. See, I was lucky. The cost-based optimizer agreed with me and did a full scan. The statistics, here they come. This particular query, if you list it, if you execute it again, you can see that it scans 5738 blocks, so 5,700 blocks. Now let's try doing this on a partition table. Remember the 5,700? Oh, here you go. So we do the same query, this time on the PT, the partition table. Here we go, table access full. You think, oh, that's not good, is it? Partition range single. It's only done that full scan on a single partition, partition number 2. And that makes sense if I look at my between condition here. So yeah, this probably did exactly what I wanted. This did what I designed it for, so to speak. There you go. And how much effort do you think it would be? Any volunteers to type in a number? Coming. There we go. Same query, this time with statistics. 1475, and that's about 25% of what it was on the full table. So yeah, in this particular case, this demo is of course totally rigged to work. And there you are. This query would become about a four times more efficient. It scanned a quart of the original blocks. And again, on large objects, on a lot of data, this is going to count. And the main point is made. If you can do partition elimination, your queries become a lot more efficient. You literally have to search through less data. And again, on large volumes, this counts. This is, of course, a laptop, so who am I? Let me reset my demo. Well, so that was the demo of the sum. Any questions? Put them in chat. There is more about queries, another slow part. If you look for the primary key, that's easy. You will have an index, and that's mostly a local index, and that'll work. If you look for something where the range is active as yes, you may have to scan a lot of data. You probably want an index on active, yes, no, but would you choose a global index or would you choose a local index? And here's the point again, if you end up looping over all the partitions, you're probably doing it less efficient. Here's the illustration. Conventional table, records all over the table, index on the primary key. You're looking for ID is 2, that would be a primary key lookup. In a conventional system, you would go to the index leaf, you would point to the table and pick up your records with about 4 IOs. On a range scan, if you're looking for all the active records in a conventional table with a conventional index, you would have a range scan, of course. You would have all the N's and a couple of yes. You would go to the yes area in the index. You would then jump to the table and pick up your data in about 1, 2, 3, 4, 5, 6, 7 gets. Probably you probably need 7 blocks to do this. Partition table. Looking for a primary key value somewhere. That's easy because I know if the primary key is 1, it'll be in this partition. So I can go that partition, pick it up, 4 blocks probably. The cost-based optimizer, Oracle, knows that this particular ID value will be in that partition. That's a big advantage. Now, if I look for all the active records, it's a different situation and I probably need a global index. There you go. Scan for active is yes. Go into the index, find the index block and do 4 jumps to 4 different partitions. That's fine. And this is efficient. This is what we would like. The problem is this is a global index. So what happens if I make that index local? Let's have a look. This would be the local index. Each index will have the N's and the Y's for its partition only. So I have 4 sets of indexed values. If I'm looking for active is yes, I'll start with the first index partition and I'll find some. But I'm not finished yet because I need to look at the next index partition, see if there's any Y's in there. one more index partition, any Ys in there? And actually I need to look at all the index partitions to see if there are any Ys in there. It can be a bit more intelligent if the cost-based optimizer knows that it only ends in a certain partition, then that's fine. But the problem you're facing is in a lot of cases, you would have to do this for say 7 years of archiving, 365 partitions. That ends up being like 1500 partitions, and it's a lot of looping. This becomes expensive all of a sudden. You're looking at milliseconds or whole seconds just to scan through that data. And that's what you don't want. This is where your design sort of failed, because this query would become very slow. Demo time. Let's do it. I'm going to find all the records with status is active, yes, and I will compare global and local index. Let's have a look. Okay. So I prepared my demo again, switching to SQL+, prepared my demo. Could somebody put an encouraging word like I can follow this in the chat, or say something like slow down? Okay. Demo, looking up a range of values. There you go. So I'm going to use a local and a global index, and I'm going to find a small set of values. First, I got an index called global index on the field called active. Here's my index, my stats. The global index is there. Let's use it in a select. I get just scrolled off the screen. So I've got a select where active is yes. There are 4 records with a yes value, and I sneakily placed 1 in every partition, of course. And I need to, there you go. So what's happening, I'm doing an index range scan on that global index, and we found the 4 records. The cost of that thing is about 2. Let's have a look at the stats. We do the same index, the same query once more. There you go. Same 4 records come back, and guess what? It did 7 block gets, like we predicted. 3 in the index and 4 jumps in the table. You know, cost-based optimizer is predictable. So it walked the index P level. It jumped at the 4 records. I got 7 IOs, and I remember I got 4 partitions. Let's try a local index. Drop my global index, create a local index, get my stats on it. Ready, same query. Select where active is yes, and same 4 records come back. This time I have an index range scan on my local index, and I'm accessing by row ID, and I'm doing that in every partition. Can anybody guess how many IOs this would generate? Answers in the chat, but I'm in a hurry. Let's run it again, have the stats in there, 12. So my guess is the B level of this in these local indexes is a bit lower. It did 3 jumps in every, it did 2 jumps in every index and 4 jumps to the table. And if you start doing this with like 1500 partitions or like 1,000,000 partitions, like Gaucho did at CERN, you end up doing a lot more gets just to get your records out of there. And this is where a local index can be less efficient than a global index. The main point was local indexes can lead you to a lot of looping. And in this particular case, the global index was more efficient. But if you don't want global indexes, you will always have to limit yourself to 1 or few partitions. And this is the design problem for partitioning. You have to find your partition key so that it's always in the query. We'll come to that. That was the demo for this one. Now, the title is Pitfalls. So what are the pitfalls in my opinion? 1, you have to avoid those global indexes because they cause you extra work when you drop or exchange or truncate a partition. And you have to avoid that partition range all. You have to avoid the looping. It's as simple as that. The consequences of that are you need to build your design proper. The consequence is that just every query in that system needs to have a partition key. It needs to know which partition to go or which limited set of partitions to go to. If you have partitioning by day and you keep 7 years of archiving, you end up with 1500 partitions. You know, just please when you query for something, add a condition that says, I only want to look at the partitions for the last month. And then you have to loop through 31 days, which is fine. But if you have to loop through 1,500 partitions, you're probably in trouble. So design, if you want to take anything home from this particular presentation, remember you need to design this. We're doing well. Normally I would now ask the audience some trivial question to see if they were still awake, or do we need more coffee and stuff like that. But I have a bonus trick, of course. When they told me it was 60 minutes, bonus trick. So I'm not saying that what I show you now is a good idea, but that always wakes people up. Now, partitions are mostly a date thing. Most of the partitions have a date component, are on time, are on range, are on order, something like that. There is another notable exception if you use list partitioning on customer IDs or customer names or states in the United States, which is a classic almost. And I haven't actually seen any good examples of list partitioning, but I'm convinced it can be used. I think everything I've seen in partitioning was always on date. And I'll tell you a secret. I think I've seen less than 15, maybe 10 systems with partitioning. I think 2 of those were a good success. The others were marginal. And most of those failed partition systems are saved by the fact that hardware is so blightingly fast that nobody notices a clumsy design anyway. So I would say no global indexing. That causes a problem because you can only have one unique key and it has to be the partition key. There's no way you can enforce uniqueness on a local index because the local index can't see the contents of the other partitioning. So I'd say if you use partitioning, please start on a greenfield design. You cannot bolt partitioning on an existing system. I've seen it tried by an American vendor, not Oracle, on a factory system in Asia. And it was just, the mess became even bigger. They couldn't fix the problem. They just made it worse, but don't get me started on that. Now, the bonus trick is you need a primary key. And ideally you put, and this is bad practice, but you could put information in that primary key. You could say, I'm picking my date, which is the Y, the D, and the S, and I'm adding a sequence of about 1 million, and I'm cycling that. And then my primary, I could choose epoch, I can try naming the epoch date, which is ends up with 10 digits plus 6 for the number behind it. Or I could try year, day number, and number of seconds in the day. I end up with 18 digits. Or I could do something really readable, and I could use the year, the month, and the day, the 24-hour, the minutes, and the second, and then add my 6 digits to that. And I end up with a 20-digit field. And that would function as my primary key. You can also check Frank Pachot's blog on GUIDs and primary keys, and his conclusion is actually don't use GUIDs because GUIDs are not really usable. You can't range them. They contain no additional value over an integer technical key. But if you sneak, totally bad practice. I'm expecting something from Tone, by the way. If you sneak a date into your primary key somehow, you can fairly easily search on date ranges. And if you reserve about 6 digits behind that, you can do about 1 million records per second. And the integer is still small and efficient. We need to discuss this after the session because I'm expecting a lot of burn on this. And you guys are right. And maybe you shouldn't do this. However, I know of a few systems where this would have saved a lot of hassle. Here's a demo. This is my hobby. The whole presentation is just to do this particular script. Okay. So what we want to do is we want to use a date plus a sequence as the primary key, as the technical key of a field. Normally, you would just use a sequence. I've just sneakily inserted a date into that. Let's try. I've got my sequence. I'm starting at a very high number so that it looks good. And I'm cycling it at the 99, I'm cycling it just before the million. So this never goes over 6 digits. And when I reach my 6-digit limit, I'm starting at 1 again. I got a table where this thing becomes the primary key, and that number has to be big because it has to contain a really large integer number. Let's have a look. If I select that properly, this would be my date part. This would be my sequence going 4, 5, 6, 7, 8, 9, and cycling back to 1. And I'm inserting leading zeros here. So my ID, my technical field in my table, my key field, would become this. And it would cycle here. The first problem someone should mention is, what if you want to insert 1 million records in a single second? The answer is you can't, and you would have to reserve an additional digit or 2. But how often would that happen? And it probably happens in your particular system, but we can cater for that. We'll just add 2 more digits. So now I'm putting that in a table, and then when I select from the table, I can see that my IDs are here, like numbers like this, and the byte size of that is only 10. So this looks like an impressive number, but it only takes up 10 bytes of storage. A GUID would take 16, for example. And this is how you can sort of work around the fact that a partition can only handle 1 single unique field. Partition table, no global indexes. That means you can have 1 unique field, and it has to be the partition key. And in my case, I would recommend you try something like this. Be very careful. This will only work in specific circumstances. So that is the end of my hobby. Any questions on that? Okay. Looking at the chat, nobody even bothers to chat anymore. We're good. Please tell me afterwards if this was interesting or not. There we go. So I come to the end of my presentation, and there's a good, don't worry, there's a couple of slides left. My summary, going back to the start, is of course, you guys probably remember, you have to design it. You can generate less redo, but you shouldn't have global indexes. And I know they're working on that. That there will be developments in the later Oracle versions. And if you really want fast queries, you need to put the partition key in every where clause in all your application code. Now, you already knew this. This is why there is a watch there. This is not my timekeeping watch. This watch means I'm asking for your watch to tell you the time, typical consultant. There are a number of surprising lot of useful cases for partitioning. Partitioning is not limited to the cloud, and partitioning, by the way, doesn't benefit from blockchain, but never mind. But the typical use case would be something like a time series. If you have a lot of data and it's time related, and that could be as simple as all the transactions of a day or transactions coming in sequentially. So time series or any time related data is a candidate for partitioning, and a lot of people probably already told you that. There is another nice case if you have fast moving data, notably with large inserts and deletions. If you need to insert a gigabyte every hour and delete a gigabyte at the end every hour, you can save half the redo because the delete could be a drop partition. And this is typical for batch operations with messages coming in. Messages are kept for about 3 months and are deleted at the end of the 3 months. The delete process is where you save when you drop your partitioning. And there is another case, and I haven't demoed it or haven't actually used it in anger, but if you use list partitioning, you are effectively sharding your data. Think about that. If Oracle tried to sell, any Oracle people on the call? If Oracle tried to sell you sharding, sharding is nothing else than list partitioning of a group of tables. Think about that. You can save money if you decide not to go for sharding, but use list partitioning. Basically, if you want to use partitioning, be my guest, get the Oracle license, etc. But it will only work successfully if you have a lot of hardware, which is fine. So you can hide your errors in the hardware, but it will work best if you know your data, you know your data model, you control your database application, you control your code, you basically have to have your partition key in every query. Cannot say that often enough. Now this, I expect some questions on, because I know most of the partition systems out there have a global primary key or don't have a primary key effectively, and generally have a lot of indexes that are not quite, that are either not local or kind of clumsy. I've seen more disasters in partitioning than actual successes, and that's the reason why I did this presentation in somewhere late 2009 already or so. You know, I fully appreciate the whole PowerPoint looks like previous decade, but that's what it is. You know. If you do partitioning, design, 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 and then you know you get my thumbs up. There are some interesting times ahead because there are improvements coming all the time, and I am particularly keen to try some of this, notably ref partitions. I would love to sort of load half a data model with a parent and 7 child tables, and then just drop the whole thing in one go. Partial indexing looks very useful to me. Hybrid partition tables. Yes, I know Roger McNichol is quite enthusiastic about it. I think it's a great feature, but I'm a bit careful. Now, whenever I am careful about a feature in Oracle, it becomes the main selling point in about 2 years from now. So hybrid partition tables probably have a great future, but to me, it's sort of kind of counterintuitive to join data in and out of the database in single queries and stuff. So be careful with that. We should discuss, you know, any of you have questions, remarks? I'm really curious to what's out there in the wild. And if we have a good discussion, I'll do another PowerPoint in maybe not next month, but somewhere later about partitioning again. There's a lot that I think can still be said. There is a lot that I think, especially new features that we should explore that I'd love to test, but I need a good excuse to do that. You know, never take my word for anything. Read the manual, test it for yourself. Make a note of this guy. Herman Beer is the Oracle product manager for partitioning. His Twitter handle is Sierra Delta July Hotel 2000. And he does reply to questions quite well, actually. My last word is always, you know, can you please explain it simple? Can you make it simple and explain it to the next colleague out there who might be speaking a totally different language? And, you know, Goethe, the German poet, always said, the limitation shows the master. If you Google that, like Bryn did, I think, and he said, Pete, you need to change your tagline. That limitation shows the master is old. So, no, yeah, but it's valid. Q&A. Basically, you can now shoot holes in me. Over to you guys.
Yes, thank you, Pete. It was amazing. Well, we have some few questions. The first one is if you can, if I understood correctly, if you can speak how the partitioning pruning can help or something like that, or how these work apparently.
How partition pruning works. Yes, I probably have a good slide for that. Partition pruning is best illustrated on here. Oh. Are you all still seeing my screen? No,
no, not yet. Just
yeah, let me go back to Zoom. Go back to Zoom, share my screen, and screen and screen. Go back to PowerPoint and find my PowerPoint. Share. Yeah, and here. You guys are seeing my PowerPoint now, right?
yes.
Yeah, this slide. This slide shows partition pruning. What you have is a table with, in this case, 4 partitions and local indexes. If you know, if you're looking for ID equals 1, so this one, you know that ID 1 is in the first partition. You go to the first partition, you look up ID1. The cost-based optimizer already knows that he doesn't have to look at the other partitions, because ID1 is the partition key, and all the partition keys between 0 and 1000 are in that particular first partition. This is pruning. And if you don't have pruning, you end up with the next one, this one. If you look for a field that is not part of the partition key, if you just say where active is yes in a query, you need to visit every partition to see if there is a yes in there. So this is not pruned. It has to go through all the partitions. And if you have a 7-year archive, you probably end up with 1500 partitions. This is not pruned. If you know that your active is always in the last month, so say sysdate minus 30 or sysdate minus 90, which is quite common actually, you can say where active is yes and sysdate bigger than sysdate date bigger than sysdate minus 90, and then you know you only have to search 90 partitions out of 1500. And then you've done partition pruning. The pruning means you've removed partitions from your query. You've removed partitions from your search set. That's what the pruning is. I hope I have explained it like this. If not, we'll do a one-on-one somewhere, but raise your hand if you understood this, or put the thumb down if you haven't understood it yet. And I'm fully aware that if when I was new to this, my first partition course was in 1998 or so, and I was wondering, what's this about? Yeah. It took me a while to get the hang of it.
I think that was clear, but yes, more questions.
Question guy, you know.
Yeah, we have 2 questions.
Yep.
That one is from Bruno that asked, he told that usually when the years change from 2019 2020, depends on how the guys define the partition, have errors or need to check again the partitioning.
Yep.
So how you can avoid this and tell to the developers to do or to change the way the partitioning?
I think this comes down to when you query a partitioned table, you need several things. But one, you need to make sure that the indexes you will use are usable. And if you've removed partitions or dropped partitions or exchanged partition data, you can have unusable indexes for a short or maybe longer period of time. That will give you an error, and you need to wait for that process to catch up, or you need to rebuild those indexes. That's one possible error. Another error can be if you are at the year change and you are trying to insert data in on a partition range where there is no partition yet. And this means someone has to manually add partitions. That used to be a problem in Oracle 8 and 9, I think 10. As of Oracle 11, we have interval partition. You can define your table in such a way that it creates its own partitions, and you're relatively safe at that. Is that more or less? Let me read the question. SAP, the database, every change of year batch used to face errors. Yeah, what could be done? Okay, to give a better example, that's Bruno. Hi, Bruno. My view is over there. Send me a mail. If you have the exact error, I can probably give you a better answer. There's an Aura dash 111555 or so, you know, rollback segment, but yeah.
I think that, thank you. I think that we have 2 questions that are related. One is there is some kind of advisor that shows if the table is good or no to be partitioned, and including with this question, do you agree that just tables that have more than 2 gigabytes are good to be partitioned or no?
That's a tricky one. I know a number of architects who will say anything above 1 or 2 or 10 gigabyte needs partitioning because of recovery and block errors and things like that. That is probably ancient knowledge, and I'm not going to give you a size. I'm not going to say that everything above a terabyte needs to be partitioned, because I've seen tables of multiple terabytes and they work, and I would probably never partition them. If an advisor, yes, I know Oracle has tried it. I know there's a Lillian Dobbs tried this in the early 2000s. He had a whole lot of scripts and questions that you could answer to see if your data was fit for partitioning. But that was mainly a sales activity by Oracle trying to sell the partitioning option. I would say common sense is the first thing. Another one is if your table is seriously big and growing over time, you probably, you can consider partitioning. But you end up in trouble if you need unique constraints on the table and they're not part of the partition key. So I hesitate a bit. The only really good partitioning is right from the start of the design. And ideally, you know whether it's on a customer list or on a time variable somewhere. Does that answer the question more or less?
Yep. And just to return. And yes, is there the...
I think we're running out of time, but oh no, we're
yes,
fine.
we have 5 minutes.
Yeah. Yeah.
So I think that
my alarm just went off and I set that for 5 minutes. So, yeah. Yeah, go ahead.
So I think that is that. We are fine.
I see the execution plan. Do we know? The quick answer to that is no, you probably need to look at the execution plan.
I have one question.
Yeah,
that is I remember something that I made in the past. What do you think about that we partitioning with, how can I say that, just to cut some details, but to partitioning using the security files and something like that, because internally we can define some parameters in security file. What do you think about that?
Yes, because especially, well, mainly if you need to delete or archive the secure files, effectively you're partitioning a table with blobs, and the blobs are in a separate segment anyway. So the careful answer is yes, probably, but only if your parent data has a proper partitioning somewhere.
Yes, the point is that we partitioning and we do the partitioning and still put the blob separated, or just put the blob is good enough?
You mean the blob? I would always put a blob not inline, but in a separate segment. And I wouldn't probably not hesitate to define one or more blob columns on a table if it needs it. I'm sort of against creating a separate table for documents or blobs, but there can be good reasons for that, by the way. And then that table becomes really big, but the size is not in the records part of the table. The size is the blob, the secure file. And only if you want to delete or exchange parts of that table will it help you to partition, I think. So my careful answer would be maybe not. And if you do partition, make sure you have a good reason for that. So I know that's not a good answer, but that's it. Yeah. Does it help, or did I miss it?
Rodrigo, have another one.
Yep.
Do you like the subpartition data?
Say that again. Do I like?
Subpartition data.
Oh, yes, I was expecting that one. The careful answer is no, because it creates an additional layer of complexity for me and others. So having said that, the first answer would be no, and I would ask why. And if the answer is I want to partition because I have proven contention on things like indexes or inserts or blocks, if you have proven contention, if you have many processes accessing the same small amount of data, then partitioning can help. There is an old trick. If you list partition stuff and list partition it so that every record gets in its own block, you don't get block contention. But that's an Oracle 9 trick. So subpartition, my first answer would be no. I know that's a bit stupid. So a lot of subpartitioning fixes problems that used to exist in Oracle 9 and 10, block contention. Not so much anymore, but there are probably people out there who can counter my opinion.
Another one, I think that we need to finish now because to the next one, but the last question is, which data type perform well during the partitioning process? Delete, truncate, which one is better? Hash, interval, time, which one performs better?
Okay, I'm not sure if the data type makes a big difference in partitioning. Searching on integers, on indexes, searching on numbers is always faster. So numbers, and a date in Oracle is a number. So numbers and dates are probably the most efficient things to partition by. And then I'm speaking of range and list partitioning. If you use hash partitioning, and I deliberately didn't mention hash partitioning in the presentation at all. Hash partitioning will solve a problem that doesn't seem to exist much anymore. Hash partitioning is to solve contention and then possibly to help parallel processing. So I'm a bit careful on this. I would almost say I'm not quite qualified to answer this question. Sorry about that.
No problem. So I think that, thank you, Pete. Now we will open to then Bruno to continue with the next presentation. That is DBA, Python for DBAs. So Bruno is with you. Now you can continue.
Hello guys, can you hear me?
Yes, you can share your screen.
Yeah, just a minute. I just start here. Okay, just a minute. So can you see my screen?
Yes.
Oh, okay. Okay, so guys, I'll be talking about begin friendly Python for Oracle DBA. First of all, thank you for the opportunity to be talking here at the Luxembourg Oracle User Group, the LuxOUG. I kind of asked that all questions should be done by the end of this presentation. Opinions expressed here are solely my own and do not express the view of my employer, in this case, Epicotech. I'm going to be talking around 40 to 50 minutes. And then we can have some discussions, and then those that want to grab some coffee or water can go back and attend the Harley presentation afterwards. Once again, I'm very happy to be here. I'm very delighted to be talking after Tom and Piet. It was two amazing presentations. So let's start. So my name is Bruno Reis da Silva. I'm Afro-Brazilian, Brazilian with Afro origin. I was born in Juiz de Fora, a a city nearby Rio de Janeiro, which is a city that most of the people know. Outside the coding world, I love to travel. I have been to some countries and I still want to travel more to learn more cultures. I do love to learn languages. I know Portuguese, Spanish, and English, and I'm currently learning Swedish. And I love working out. I'm Oracle Ace. I started at IBM in 2011 as a junior Oracle DBA. And then after 2 years, in 2013, I became an IBM employee. And after 5 years working for IBM in Brazil, I got a promotion to IBM Hungary in Europe, Central Europe. So I worked for 2 years in Hungary, and after work for 2 years in Hungary, I got a promotion to Sweden, and I have been living in Sweden since October 2018. And after after 9 years work for IBM, after this summer, I'm joining an Oracle partner called Epicotech. It's former known as Miracle Sweden. And then for the first time, I joined an Oracle partner as Oracle consultant. As I said, I'm Oracle Ace, and here you can find my social medias, my Twitter, my blog, my GitHub. I'm IBM, Oracle, and Group certified. I'm collaborator of the Luxembourg Oracle User Group and member of the Swedish Oracle User Group. Okay, as you guys could see, I have been moving quite around. I worked remotely in Brazil, Hungary, and Sweden. You can see here those countries in blue. And those countries in red are the countries that I worked in projects remotely. So North America, in the United States, in Spain, in Germany, and also in India. Okay, but now let's talk about the Oracle ACE program. This program has 3 levels: Oracle ACE Associate, Oracle ACE, and Oracle ACE Director. And it is a program that Oracle Corporation gives to those who contribute in the Oracle community with these skills. So if you like to write posts, articles, to give presentation and sharing your knowledge, and you feel that you are entitled to receive this credential, you can nominate yourself. Or if you know someone that attends this criteria, you can submit an application at acenomination.oracle.com. And here it is a slide regarding the Oral World magazine. This is a free magazine that you subscribe yourself, and you receive Oracle newsletters, tips about presentations, articles, everything that is related to the Oracle community. I do recommend those who didn't subscribe yet to subscribe there, because it's very interesting. There are many Oracle ACE, Oracle ACDs writing there. So if you want to be up to date about Oracle news, I do recommend subscribe in this magazine. So, okay, what to expect of from this presentation and the reason behind of it. The DBA role is evolving. So you can like it or not, but the role of the DBA is changing. And qualified DBAs who wanted to maintain or advance their positions will need to work on some new skills. On the next slide, I'll be showing on a web page from Oracle that it shows how the autonomous database will affect DBAs. And automation is becoming more relevant. So some programming language as Python and some open source orchestration tools such as Terraform are becoming more often in the DBA base. And this lecture is also a kickstart of Python programming languages. I'll be talking about some key concepts that you can go deeper in the topics afterwards to start developing your own scripts or application in Python. Oracle database and multi-cloud is already a reality. Some tasks that the DBA used to perform were replaced by the autonomous database. And Oracle database engine has been created as a service in several cloud providers. Python is freely available for most of the operation systems, for many platforms, even Raspberry Pi. And my main goal on this presentation is take you from the scratch until the cloud era. By the end, you want to be a Python expert to automate all your tasks in your database, but you know where to find the information. And keep studying to be a good programmer afterwards, DBA with some Python skills. So, but if you are already an expert in Python and automating your task with programming language, stay tuned at my GitHub repository. That over there, I have been creating an application that I will be deployed into Oracle Cloud using Oracle Autonomous Database. And this might be a new topic in the future, I don't know. But by now, let's start from the scratch in this one. Okay, so here is a white paper published by Oracle Corporation, where you can see several topics about how autonomous database has been affecting the DBA role, where Oracle provides 10 advice. So first one is the pivot. Oracle wants that you know more about the data that is inside of your database. And I'm not talking only about data types, but also the business information regarding this data. Learn what is the impact of your data in the business perspective. Create. Learn the diagram and the structure of your data. Evolve. Be aware about the security of your data. Learn. Keep your eyes in the Oracle newsletter. Experiment. Try to join in an Oracle beta tests as a volunteer. Collaborate. Learn agile methodologies. Big and small IT companies have been using it for a while now. And if you don't know about this methodology, I would suggest you to get started. Innovate, learn to create a wise data to make new revenues. Analyze, learn the path of your data to automate process. Orchestrate, you can manage your database on-prem, but learn opportunities and be ready to see this data in Oracle Cloud if and when decided. Strategy, don't be stuck in SLA. Be on of your time and daily activities. Okay, so then in this era of cloud and DevOps expansions, a lot of questions start to arise in the DBA mentality. And some of these questions are towards one of the most useful programming languages in this era, Python. So let's go through some questions and let's try to answer some of them. What is Python programming language? Okay, Python is an interpreted high-level general purpose programming language. It's Guido van Hoosen. He's a Dutch guy. He is the creator of this language. And the first release of Python was in 1991. It is an easy and intuitive language, just as powerful as major competitors. It's open source, so anyone can contribute to its development. Suitability for everyday tasks, allowing for short development times. And Python is case sensitive, so BR in upper letters are different of BR in lower letters. And comments starts with hash. And it's pretty similar PL SQL, but not the same. But if you already know PSQL, it's a plus. So, okay. So I will go through in some key concepts, starting with types. A type is how Python represents different types of data. You can have different types in Python. They can be integers like 12, real numbers like 12.21, and they can be even words. Floats stands for float, which means essentially a real number. They include the integers, but also numbers in between integers. For instance, consider the numbers between 0 and 1. You have 0 0.1, 0 0.2, 0 0.3, 0 0.5. Those numbers until 1, they are considered as floats. So floats can be an integer as well. Then you have types. Then you have the type string. A string is a sequence of characters. And Boolean is another important type in Python. A Boolean can take on two values. The first value is true. Just remember, we use an uppercase T. But Boolean values can also be false with an uppercase F. If we cast, which means that if we transform a Boolean to an integer or float, we'll get 1 as a result. And if we cast a Boolean false to an integer or float, we'll get a 0. But if we cast 1 to a Boolean, then you get true. Similarly, if you cast a 0 to a Boolean, then you get a false. In simple words, true it's equal 1 and false it's equal 0. Okay, then you can change the type of the expression in Python, and this is called typecasting. You can convert an int to a float. For example, you can convert or cast the integer 2 to a float 2.0, and nothing really changes. You not lose any data. But if you cast a float to an integer, you must be careful. Why? For example, if you cast the float 1.1 to 1, you will lose some information. And if a string contains an integer value, you can convert it to int. If we convert a string that contains no integer value, we'll get an error. So be careful while you convert from float to integer. And then you have expression. Expression describe a type of operation the computer performs. Expressions are operations the Python performs. For example, here we have 5 plus 10, which is equal 15. We call the numbers operands, and the math symbols, in this case, addition, are called operators. Unlike math, real-world operation, we can perform multiplication operations using the asterisk in Python. Okay, and then we have variables. We can use variables to store values, like PSQL. So here you have an example that you have a variable called salary that has the value of 500,000. It's a float. And then you have another variable called name, which the value is race, and it is a string. And I'm printing both of them afterwards. Other key concept is tuples. Tuples are an ordered sequence. It's called compound data types and are one of the key types of data structures in Python. Tuples are expressed as comma-separate elements with parentheses, and all different types, strings, integers, float, can be contained in a tuple. But the the type of variable, this variable is also a tuple. Tuples are immutable, which means we can't change them. So here you have an example of a tuple called numbers. And other popular data structure in Python are the lists. Lists are also an ordered sequence. Here we have a list called B, which you have essentially 3 values. LeBron James as a string, 15.2 as a float, and 1975 as an integer. And in many respects, lists are like tuples. One key difference between tuples and lists is that lists are mutable. So this means that we can change them. And unlike tuples, lists can contain strings, floats, and integers. Then you have dictionaries. Dictionaries are a type of collection in Python. Sometimes are also called key value pairs. And a dictionary has keys and values. So you can see that there are key 01, key 02, key 03, 04, 05. And the key is analogous to the index. To create a dictionary, we use curly brackets. And the keys are the first elements. They must be immutable and unique. So this means that you cannot change them and they must be unique. And each key is followed by a value separated by a column. The values can be immutable, mutable, and duplicates. Each key and value pair is separated by a comma. And you have sets. Sets are also a type of collection in Python. So we have been through in many types of collections. So sets are also a type of collection in Python. This means that like lists and tuples, you can input different Python types. Unlike lists and tuples, they are unordered. This means sets don't record element position. Sets only have unique elements. This means there is only one of a particular element in a set. To define a set, we use a curly brackets, and you can place the elements of a set within the curly brackets. So here it is an example regarding one list. So we have a list called players underline list that has the values Ronaldo, Real Madrid again, and 2001. And then I'm converting this list to a set. So after the conversion, you can see that now I have just one Ronaldo value and also only one Real Madrid value. So as you could see, set, you should have unique elements. And then you have 2001 as the value. And then you have functions, which is very important because in functions, you can use Python's built-in functions, as well as also build your own functions. Functions take some input, they produce some output or chain. This is the big meaning of use a function. The function is just a piece of code you can reuse. You can implement your own function, as I said, but in many cases you use other people's functions. So it's very important you know how to read code. And Python has many built-in functions, so don't get concerned. Oh, shall I learn all these built-in functions? No, you don't have to know how those functions work internally, but simply what task those functions perform. So then you also have objects. And as I said, Python is an object-oriented programming language. Almost everything in Python is an object with its properties and methods. In this example, we have a class named myExampleClass with a property named D and an object named B1 that print the value of D. And it is important to understand the built-in function to really understand the meaning of objects and classes in Python. Why? Because all classes have a function called init. So, which is always execute when the class is being initiated. And this function is used to assign values to object properties or when objects are used. So you can see here that we have a class called customer. Then you will have this init function that receive the values of the object P1, and then afterwards it's printing the name and age received in this function. So down there you have Maria 52, which is printed. But objects can also contain methods. Methods in objects are functions that belongs to the objects. So I use the same code as before, but now it was inserted a function that prints a phrase and execute it on the P1 object. So, okay, now that we have already went through on some keywords, what can you do with Python? Is this a Python lecture? Will I become a programmer? No, I'm just showing you what you can do with Python in order to use in your DBA activities. So what can you do with Python? So here is where you can check all the documentation about this programming language and stay up to date about new features. And if that friend or this co-worker that is in the DevOps, the department starts to talk to you about Python and how you can use this in your database, you will see right now. So, okay, when it comes to Oracle systems, you can install in a Oracle Linux, where Oracle has a full documentation about Python for Oracle Linux. So here you have the documentation. It's iom.oracle.com and then Oracle Linux python.html. So there are many steps, what's Python and everything you should basically know to get started. And you can perform the installation for several Oracle Linux versions. And when it comes to the version 6, by default, it comes with Python in the version 2.6 installed. However, if you want the other versions, you can download it from the Oracle iom repository. And unlike the version 6 that comes with Python in its version 2.6, the Oracle Linux 7 by default has Python 2.7 installed. And an interesting thing about the Oracle Linux 7 is that from the version 7.7 of Oracle Linux, it's already including Python 3, which is the most recent version of Python. So here are some examples to check the version of the Python installed in your system. So it's pretty simple. You just type Python -" version. So you could see here I I have put two examples. So one in Oracle Linux 6.10 and another one in Oracle Linux 7.6. Oracle Linux 8 as default comes with the Python 3. So, okay. But how can I use Python to create a script or application to connect to the Oracle database software? To be able to do that, you have to install the CX Oracle module. CX Oracle module is a module that enables access to Oracle database and conforms to the Python database API specification. This module has its own documentation, as you can see in the slide. CX oracle.readthedocs.io, and over there you can find the most recent version and also the previous version of this module. But if you want to use Python and Oracle database, especially to create scripts or application to connect to your Oracle database software, you must install this software, this module. Okay, so as in this example, I wanted to use Python in its last version, and one of the first things to do to use the 6x Oracle module is to have Python installed. I have shown here how to perform an installation of Python in Oracle Linux 7.6 from the Oracle Linux 7 latest repository. So I just copied here. I'm not good with demo, so I just prefer to put my output here. So it's pretty simple. It's just a simple command yum space install space -y, and then the version of the Python you want to install, in this case Python 3, and then it will download from the Oracle Linux 7 latest repository. But and now we have to install the CX Oracle module from the Python package index, which stands for PYPI, which is a repository of software for the Python programming language. And then once again, you just type to install this module inside of the Python that you are using. In my case here, Python 3. So Python 3 space -m space pipe space install, and then CX Oracle, and then space -- upgrade. If you have it should be upgrade. If you don't, it should be installed. But in this case, it was not installed yet, so I just have installed. So now that you have installed the CX Oracle module and you have already installed the Python in the version that you want, in this case Python version 3, you will need to install the Oracle instance client. Why? Because CX Oracle module use Oracle instance client. So you can either download the Oracle instance client zip files from Oracle documentation, or you can perform the installation using the RPM package. So here I put an example of an installation of an instant client installation for Oracle Database 12c Release 1. But after install the instance client, you have to add the instance client to the runtime link path if there is no other Oracle software on the machine that it should be packed. So you just basically export the LD library path variable to where you have installed your instance client. And this procedure you can also find in the CX Oracle module documentation. Everything is available there. And I won't show a database installation, but of course you need to install an Oracle database software. You can install the version that you want. Here it is an example using 12C release 1, which is pretty old, but it was the version that it was in the project that I was working. So just enjoyed to use that environment. But I would suggest you to use the 18C version, that is the 12.2.0.2, or either the 19C, which is the 12.2.0.3, or either the version 20C, 20.1.0. And here I have created a database called PythonDB. So, okay, and my idea, it was, okay, I want to connect to the PythonDB database and perform a simple script, just to give me a glimpse what I can do in the future. I can create a report of all status of my users, or all inusable index, whatever. It's just a glimpse what you can do. So here I have created a script called myconnectdb.py to connect to the database and count all users. So I'm using some functions, and afterwards I import the CX Oracle module. And using the CX Oracle module, I'm connected to my database with the user C /Bruno RS, my password, and my server name, and my database service name. It's not a good practice. I'm not telling you, okay, you should create a script and put your password and use. No, but you can improve this script and also hidden your password, your user, your password. Once again, this is just a glimpse what you can do when automating tasks using Python. And then I create a cursor, and inside of this cursor, I just put my simple SQL to select all the users in my database. So then afterwards, I just execute this script, Python 3 myconnectdb.py, and just show that I have 36 users. But okay, it was one idea that you can perform in your daily activities. Now imagine that the situation that you want to compare. You want to compare files, for example, files that are going to be used by an Oracle external tables. So in this case here, I have the file tag table 1 and tag table 2. Both of them are text files, and both of them have 4 lines. And my idea was, I wanted to compare each line of each file. So for instance, I want to compare the first line of my tag table 1 file and with the first line of the tag table 2 file. So how could I do that? So to do that, I have created the script named compare table files.py. So then I use the Python's built-in open function to create a file object and obtain the data from both files, file 1 and file 2. And as I could apply a method to that object to read data from the file, I create a variable named n that is updated in a for array, and depending of the conditions inside of this array, it should be printed if the lines are have the same values, or in case if those lines are different, it will print the value of the first line in the file 1 and the first line in the file 2. So here you have the execution and the output. So as in my scripts, I mean in my files, I didn't have any line that had the same values. You could see that it was printed in this way. The line 0 at the file tech table 1, it's Brazil, and the line 0 at the file tech 2 is Italy. And again, line 1 in the file 1, line 1 in the file 2, line 2 in the line 1 in the file 1, line 2 in the file 2 as well. Okay, but then you as a DBA, you may be wondering right now, okay, is that worth to do that? Okay, just think, you are used to perform some bashing script. You are used to creating script, but now with machine learning and DevOps expansions, you can also try to think not only in bash script, but also in Python, especially because Python, you can use this in many platforms, not only in AIX or Unix, but in many platforms. So it's a bigger field, and also it's very powerful because it gives you many ideas. For instance, okay, just using this script that I have here right now, comparing those files, I can think when I'm going to build Oracle Data Guard, and then I want to check the Oracle in each file, in the source and the target. I want to see some values that are different that may lead for some problems in the future. So I can simply run this simple script, and then I can compare the values in both files. So it's quite useful nowadays. But then now here we are. Okay, now we have went through about some basic concepts about Python, some example what you can do about that. But how about Oracle Cloud Infrastructure? So when it's coming to the OCI, Oracle Cloud Infrastructure, you have the Python OCI SDK, which is used to load data into an autonomous database. You have OCI CLI, which is the command line interface, which is really good. But if you want to develop your highly customized tools, I would suggest you and recommend using SDK. And then you have Oracle Application Container Cloud Service to deploy a Python application to Oracle Cloud. And this service lets you deploy Java SE, Java EE, Node.js, PHP, Ruby, Go, .NET Core, applications, not only Python applications, to the Oracle Cloud. So it's a very powerful service. And as I said in the beginning of this presentation, currently I have been developing an application that I will be deploying to the Oracle Cloud and upload in my GitHub profile. And in this application, I will be using this service. So here you have the documentation. It's a very, very funny presentation, nice presentation as well. And you just have to follow 3 steps to deploy your application. And those steps are very, very good detailed in Oracle documentation. And you may think, okay, it's quite hard to learn. I'm not going to use this, but it's very useful. First thing you have to do is create a Python application and prepare the application for deployment. In the Oracle documentation, you can really find how you can do that with all details, and it's pretty nice. And then deploy your application to the Oracle Application Container Cloud Service. Okay, but now we went through about some questions. What is Python programming language? What can you do with Python? But how about Python and Oracle DBA career? And since I start work in Sweden, I joined in a project where I was requested not to manage the database, but try to automate some repetitive tasks. So here in Sweden, I've been working as an Oracle DBA and also Oracle Cloud Support Engineer. And in this parallel role that I have been working here, I start to think, how can I make fast this process that we are doing every day? So it is what I want you to do. Like, what task you and your team have been executing every day that could be easily solved just by a Python script. Most probably you have this type of process in your team. I've been working in many projects that I saw that many processes that could be automated. So why not with Python? It's pretty simple. And then, okay, let's go back here and talk about the Python and the Oracle DB career and why shall I learn Python. Okay, many vacancies has been requesting Python skills, and even some of them are called DevOps DBAs. So here is just an example. It's an Oracle database administrator level 3 role. It's requiring a French speaker. So I took this from a French job market, and you can see that down there it's requiring preferred expertise programming in Bash, Perl, and Python. And then you think, okay, this is just an exception vacancy, but not. If you go through about many vacancies nowadays, most of them, or the majority of them, have been already requiring Python. So then this one it's for the States, so it's an Oracle DBA role. So then they put exactly what I spoke a few minutes ago. If you see in this line, expertise on database versions 11G, 12C, 18C, including upgrades, and expertise with automating repetitive tasks using shell / Python script. And then you have this other one that I don't know where, in which country, but it's also it's requiring experience in SQL, DDL, DCL, and DML, which is quite core for us, DBA, but it's requiring PowerShell, Python, and shell scripting as a plus. So you have seen that many companies are already requiring that. So before we go to some questions, I'd like to say that I'm going to speak on 2 of July at Oracle Groundbreakers with the topic Begin Friendly for Oracle Techies. The topic of this presentation to be Begin Friendly Python for Oracle Techies. It should be not only for Oracle DBAs, but also for more developers. So it should be on Thursday, July 2, and it should be 3 to 4 p.m. in GMT time, and it should be the all Oracle user group in Ninja. They are going to provide many speeches from 1 of July until 16th of July. So yeah, now here you can see my Twitter, my blog, my GitHub, my email. My social medias are quite blurry here, but you can see, I guess. And if you have any feedback or questions, this is my email. And we have got like 11 minutes before Haley starts. Do we have some questions?
Yes, Bruno.
Yes, Bruno. We have one. First, thank you, Bruno, to share your knowledge and share your session. The point that we have in here is Python and Ansible for repetitive tasks. What do you think about?
Okay, I used to execute Python more as a bash. So nowadays, instead of using scripting, I'm using more Python to automate some tasks and also to deploy application. So Python is too powerful that I would say not only for repetitive tasks, but also for developing applications. As I said, I have been currently creating one application, but I think Ansible I use more to perform migration, not migration, but deployment from database on premise to cloud. So for repetitive tasks, I would prefer Python, but Ansible more like for migrating from on-prem to some cloud providers. For instance, also not only Ansible, but also Terraform. It is another orchestration tool that I use also to migrate from on-prem to cloud. But for repetitive tasks, yes, you can simply create script or applications to execute what you are doing every day.
Okay, Bruno. And another question is, with your expertise and experience regarding about the Python nowadays, what do you think about the DBA role? It will disappear? It's changing? It's a cycle?
I don't say that the DBA role will disappear. Actually, I was having this conversation with a friend of mine, and no, I don't think that it will disappear, but clearly the DBA role is evolving. So if you just be stuck, okay, I know the core of Oracle, and I just know the core of database, it's not good nowadays, because it's requiring you some skills, not only in programming Python, but also in cloud, as Oracle Cloud, AWS. So I don't think that it will disappear. Actually, I think I see this in another way. I have seen that it's evolving. So those that, as I said in the beginning of this presentation, those that are keen to learn more the database will be advanced with this new era that we are now. Cloud, programming language, you all the time hearing about machine learning. So yeah, I think it should not disappear, but you should open your lack of knowledge.
Okay. And we have another one from Rodrigo. Which books do you recommend for someone that is starting is DBA and is starting to move and need to learn Python?
Yeah, it's a pretty nice question. There is a series on Oracle technology network that it's that they had like 10 chapters about Oracle about Python for Oracle DBAs, and I found some articles about Oracle and Python, but none of that was that very detailed as the Oracle OTN. So I do recommend for now the Oracle Technology Network and the articles that we have there, and also Arup Nanda, he provides a lecture exactly about this topic, Oracle for Oracle DB, Python for Oracle DBAs.
Okay, thank you. Can you share your screen again? Because Roberta Ives is requesting you to show the link about Oracle Cloud that you put in your slide.
Okay, just
about Python tactics.
Yeah, I just have to go through here.
Or if you can pass in the chat.
Yeah, I'm just trying to see which one here. I think it's not this one, right? I think
is a slide about Python tactics with Oracle Cloud.
Yeah, I think mainly it's because it's this one here. Oh, okay, I'm going backward. Is this one? Are those here? Just a minute. I don't know if I can copy and paste, but after
you can share his screen again, and you pick up the.
But I'm not able to see my screen right now.
No, I put in my one. I return to the template, but you can ask to share again.
Okay. 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 Sure. And then I think here is like so. I think let's go for here. Okay. Yeah, I think I'm not able to copy right now, but as soon as I finish my presentation here, I can just copy and paste.
Yes.
Can I do that?
Yes, you can copy and paste, but Ivis, the presentation will be online. will be available later at YouTube, so is there. And you can, Bruno, can you put your Twitter and your email so you can send directly to Bruno?
Yeah, I can show here as well. But as soon as I stop to share, I also do that right now here. Yeah,
Yes.
so here, and also I'm open for feedbacks and questions regarding all topics. And as I said, I have been developing an application for an application in Python that where I'm going to use this contain server. So stay tuned at my repository, because over there I will be writing all scripts that I will be using to build this application.
Okay, Bruno, thank you so much.
Yeah, and I do appreciate the time of those that are here. And now we look forward for Heli, that is in Helsinki. Helsinki is pretty close here. So thank you, guys.
Yes, now the next presentation is Heli. So will be about machine learning. So welcome, Heli. I don't know if I speak your name correctly, but the session is with you, and you can continue right now.
Thank you. Can you see my screen?
Yes, working perfectly.
Good, because I'm a little bit confused now because it shows differently to me.
Okay.
Now we are good. Can you still see it?
Yes, amazing.
Good. So hi everybody. It's quite late already. I'm sure you're pretty tired, but I hope you still have the energy to listen what I have to tell. We are going to talk about machine learning, and a short introduction. What is machine learning all about? So my name is Heli. The last name is Helsky-aho, but nobody can pronounce it, so you actually know me as Heli from Finland. I have graduated from University of Helsinki with a master's degree in computer science and currently working on my doctoral studies. And those are, surprise, surprise, related to machine learning, and that's why I'm so excited about machine learning. I've been working with Oracle for many years, since 1993, and on IT even longer than that. Anything to do with data and databases is very close to my heart, and that's why I find machine learning very interesting, because it's all about data. I'm a CEO for Miracle Finland, a small consulting company in Finland, Oracle ACE Director, and Oracle Groundbreaker Ambassador. To my huge surprise, I have been listed as one of the top 100 influencers on IT sector in Finland 5 years in a row. I'm a public speaker and an author. This is a surprise to everybody, since I just said I'm from Finland. Finns are known to be very quiet people, and I just go and speak. That is strange. I have written 2 books. The first one about database designing, and the second one I have co-authored with 4 other people about SQL and PL SQL. Currently working on the 3rd book while I'm working on my doctoral program as well. So quite busy at the moment. And then to the topic. What is machine learning? It is the very important part of artificial intelligence. I would say there is no artificial intelligence without machine learning, because it's the heart or the brain of artificial intelligence. So machine learning teaches computers to learn from experience using the algorithms. Learn from data and make predictions. It's about mathematics, it's about statistics, and it's about your business. More formally said, it's a field of study that gives computers the ability to learn without being explicitly programmed. This is how Arthur Samuel described machine learning in 1959. So machine learning is not a new thing. It's actually older than me, so quite old thing. In other words, we could say that machine learning is a systematic study of algorithms and systems that improve either their knowledge or their performance with experience. The reason we talk about machine learning now is challenges in big data. Big data is not the hippie word anymore. It's kind of gone, but the problem still exists. We have more and more data, the volume. We have different data models and different data formats, the variety. The loading is in progress while we are already trying to do data exploration. the velocity. Not all the data is reliable, veracity. So we are used to have data that we trust. Our invoicing system, our orders, and so on, we know it's true. But if we are using data from different sources, we cannot anymore know if it's true, if it's fake news, if it's completely something that has a bug or a virus or whatever. One of the biggest problems is that we actually don't know what we are looking for. We have a lot of data from different sources in different kind of data formats and models, and we don't even know what we are looking for. So that's the value, viability, variability. And also, a very big problem is that actually the business experts are non-technical users, journalists, investors, politicians, big bosses, whatever, people who are not technical. They don't want to use Python or SQL or any language to find information or knowledge from the data. They want to find it much, much easier. So we need to have visualization. And all this must be done efficiently and fast. And the only way to do that is we do it as much as possible by machines. And that might mean that we should be using machine learning. Also, it's much more possible than it was 1959 because we have improved technology. We have GPUs, we have TPUs, all kind of improved technology. And the price for storage solutions has gone down. So we are really able to store the data. We have existing data sets and pre-trained models that we can use to build our models faster and make them learn faster. And we have fantastic research that improves everything every day. I put FB here to remind me that I will say something positive about Facebook, because usually what you read about Facebook is negative, but there is something positive as well. They do a lot of research and they publish their research. So other people can also use whatever they publish. So all kind of research, not just the universities, like my university is doing great research on the area, but also companies are doing research, and some of them even publishing whatever they find out. So we are living in an environment that needs machine learning, and it's finally able to really use it. That's why we all talk about machine learning. So when should I use machine learning? When you have data. It sounds so stupid, but it's a fact. If you don't have data, machine learning will probably fail completely because it is, well, there's an exception I will mention in the end of the presentation where you don't need to have the data, but in general, when you are doing machine learning, you need to have a lot of good quality data. The rules and equations are complex, like for example, image recognition, or they are constantly changing, like fraud detection. So something that you cannot program with if and else, it's more complex than that. It might be a use case for machine learning. But bear in mind that machine learning is not a silver bullet. So if you have a problem with your data or with your business, it's not a silver bullet. It's not the solution for everything. It might be the solution, but we can't guarantee it is the solution. The biggest problems why it might not be the solution are usually the task, the problem that you are trying to solve with machine learning is actually very hard to define. So you can't actually define what you are trying to do, or the data is not enough, it's not good quality, or it actually doesn't have solution for your problem. So usually it's about the data that we struggle when we are trying to use machine learning as a solution. Well, the nature of the data changes and the program must adapt. That's what machine learning is about. My favorite example is predicting shopping trends. So I have two sons, and the younger one is very keen to fashion. So he always knows what's the coolest thing ever. So when I'm traveling, I try to be the cool mom and buy the hoodies that are the latest brand. By the way, all those brands, they are impossible to pronounce if you have noticed. I don't know how to pronounce them. So I always have a note with me that says the name of the brand, and I try to find the shop and buy the hoodie. But the problem is, When I get to this shop, and those hoodies are, by the way, very expensive. I get to the shop, I buy the hoodie, I manage to do all this, and I'm so proud. I'm the coolest mom on the planet. I come home and I give this hoodie to my son, and he's like, Mom, this is so last season. Nobody wears this brand anymore. Now we are all using this and that brand. So if I had machine learning model predicting me the next brand, I might be the coolest mom on planet. Currently, I'm not, unfortunately. So some real life use cases for machine learning. Well, spam filters is a very classical example because it's very hard to program if and else for spams because spams are changing all the times. Or log filters or log alarms. Data analytics, image recognition, speech recognition, medical diagnosis. My favorite thing is medical diagnosis because there's so much you can do with machine learning on that area. Robotics, okay, robots are very nice. They can be so cute and so efficient, and they can do the vacuuming for me so I don't have to vacuum my house. By the way, I still don't have this robot to vacuum the house. It's my dream. And of course, the self-driving cars and so on. So many interesting things could be real life use cases for machine learning. So what is this machine learning then? Well, you can actually say it's three different kind of things: unsupervised learning, supervised learning, and reinforcement learning. Unsupervised learning is finding hidden patterns or intrinsic structures in input data. It could be clustering, it could be anomaly detection, all this kind of things. So we are playing with data we actually don't know so well. Supervised learning trains a model on known input and known output data to predict some future outputs. Typical examples, classification and regression. And then reinforcement learning, the machine or the software agent learns based on the feedback it gets from the environment. Let's talk a little bit more. So I said unsupervised learning is learning from unlabeled input data, so data we don't know. We are trying to find some kind of patterns from that data. We have no target, so we don't know what we are trying to predict. We are just trying to understand the data. This is typically used when we don't have a specific goal. We don't have a target variable. We are not actually sure what information the data contains. Or we might want to reduce the features of the data as a pre-processing for supervised learning, called dimensionality reduction. The most used use case for sorting this data is clustering. So putting data into clusters. There's two different kinds of clustering techniques: hard clustering and soft clustering. In hard clustering, each data point can only belong to one cluster, while as in soft clustering, it can actually belong to several clusters. So we are trying to find clusters where this data belongs to. Anomaly detection could be unsupervised or supervised learning, depending on the task we are trying to achieve. Anomaly detection is trying to find something unusual from the data. So something that is not normal. Supervised learning is learning from known input and known output data. And the target is known. We are trying to predict those employees who are about to leave our company. We want to find them before they make the decision to leave. Or we want to find the customers who are most likely to buy a certain product. So we have a target and we want to find a way to predict that target for new data. We are training the model using known input and known output, and then we are testing it using another set of known input and known output data. Then we compare how well did the model success with predictions. If it's good enough, we can just deploy it to production. If not, we have to do something. But the key here is that we have to have two sets of known input, known output data for training and for testing. So classification is a classical example of supervised learning. So we are setting classes. So we are trying to find cats and dogs, or we are trying to find horses, cats, and dogs. And when there's a new picture, we have to know if it's a picture of a cat, dog, or a horse. So setting things into classes. Yes, no, cat, dog, and so on. This is what classification is all about. Another example of supervised learning is regression. Regression is about numbers. We are trying to predict the next number. What's the temperature next Monday? How much will I get from my house if I sell the house now? How much would I get it? How much would I get from the house? And so on. So predicting numbers. That's what regression is about. So classification is putting things into classes, and regression is predicting a number. Every time I talk about machine learning, somebody asks me, what is deep learning? Because everybody talks about deep learning. Well, I just mentioned the cats and dogs. Is the picture a cat or a dog? That could be a supervised learning problem. That could be also solved using deep learning. So deep learning is different from this regular supervised learning by the fact that actually deep learning is doing feature extraction for us. Feature extraction is a lot of manual work, a lot of understanding the data and trying to understand what are the features, the columns, the attributes, those elements that are important for predicting if it's a cat or a dog, or if it's a car, like in this example. So instead of me doing the feature extraction, the computer will do that for me as well. Well, this sounds like a dream come true. I don't have to do anything. I just let the computer do everything. Well, being honest, it's not, because of course it has its downsides as well. So if we are using deep learning, it demands much more resources than just regular supervised learning. So I need more time, more memory, more computing power, more this, more that, and especially more data, because it needs to do so much more. So deep learning is not a silver bullet either, but for some problems, it might be a perfect solution. So examples for deep learning, like computer vision, face recognition, speech recognition, text processing, a lot of different kind of use cases where we could use deep learning, but it needs a lot of data and a lot of resources. The good thing is that we have already data sets and pre-trained models that we can use for transfer learning and for speeding up the learning process itself. So for those reasons, deep learning is much more able to do things now than it was before. There was a time when deep learning was already doomed as not usable, but now because of all these and GPUs and TPUs, it is possible to use deep learning for many, many use cases. Another thing, especially for image recognition, is a thing called convolutional neural network, CNN or ConvNet. So it starts here with the input. So we have an input of a dog face, a picture of a dog, by the way, very cute dog, isn't it very nice? It goes first to convolutional layers before it goes to neural network. Convolutional layers consist of filters, output and pooling layers, and that the result will be flattened to neural network to process. So all these convolutional layers make it even more possible to use deep learning techniques for image recognition. Another question I often hear is, what is backpropagation or backward propagation? So it is the process for neural network to learn, because I will show again the slide where we have the neural network. So it's about neurons that are connected to each other. So when this neural network is learning, it actually happens with backpropagation, because the first time we set up the network, we are guessing all the hyperparameters. Hyperparameter means a parameter that is defined before we even start the machine learning. Like for clustering, how many clusters shall we have, and so on. So all these kind of definitions need to be done before we start actually building the model, and they are called hyperparameters. So all those hyperparameters that are needed for neural networks are guessed. So we just have a guess what to put here. And we are using backpropagation to adjust those guesses. So we have input X on top of the screen here. Input comes to all the layers we saw in the picture, and we make a prediction. Then using loss function, we see how far are we from the true targets. Remember, we have to have known input and known output to know how we are doing. So we know it should actually be a dog, but for some reason, the model says it's a cat. So the loss function tells us how far we are from the truth, uses loss score to actually use the optimizer we have selected. The optimizer updates the weights. Weight is one of those elements that we have as a hyperparameter. And the backpropagation name comes from the fact that they actually start from the back. So we go to the furthest layer first, the one that is closest to prediction, and we go and update that first. Then we go to the next layer and next layer and next layer and so on. So we go backwards. So using the loss function and optimizer, we are able to actually teach our neural network. So these examples for deep learning, text and voice are actually very good examples because text and voice are quite complex. Natural language processing, automatic speech recognition, text-to-speech transformations, machine translations. By the way, it is actually very good already translating Finnish as well, which shocks me every time because Finnish language is quite unique, very strange language. It can build you resumes or summaries of a text. And all these kind of cool things that actually make people worry that maybe in the future, our great-grandchildren don't even have to learn to read anymore. Because why to bother? The machine is doing everything for you, giving the resume, reading the text for you, translating it to whatever language and so on. But I hope this concern is nonsense because reading is so much fun. And actually, I wouldn't trust the machine do everything without me understanding what it's doing. So my reading skill is probably needed also in the future. But people do have worries on different kind of things. So I tried it. I tried the talk to transformer, which is one of these tools that will build text based on some words that I give to it. And I put here, Heli Helskoha will explain machine learning in 25 minutes of dev around the sun event. And it gave me I was hoping it will give me a perfect abstract I can use for my next presentation, but probably I will not because Heli Helskoha will explain machine learning in 25 minutes at dev around the sun event to promote the use of HANA to enable complex machine learning for large-scale cloud computing, workshops for developers and companies on cloud computing, and so on and so on and so on. Well, sounds very interesting, but definitely not my abstract. I used another tool, text generation API, and I put the same text here. It gave me a very nice abstract. Heli Helskoha will explain machine learning in 25 minutes at dev around the sun event and at Microsoft Exchange. I want a machine that can make decisions that you don't have time for. I know how to get an idea and you can think about a machine like that. Oh my goodness, this is definitely not my abstract, but very fun to read. Translations are also interesting. This is just Google Translate. I put here Finnish and I translate it in English. So in Finnish, I actually wrote here that Heli will give a presentation about deep learning at Apex Connect event. What it says in English here is Heli will give a presentation on in-depth learning at Apex Connect. So it didn't know the word deep learning and it was thinking it's in-depth learning. So it doesn't know all the words and the nuances in words, but still it's already pretty good in translating things. It used to be very bad. So I'm quite happy about this progress. And also what's different in translating, the translations used to be from one language to another language, from the same language to another language, and so on and so on. Now it's been actually using the same model to translate to different languages. So you don't have to build several models for each of the combinations, but you can use one model that will do the transformations for or translations for many different languages. Recommender system is a very classical example where deep learning might be used. So a recommender system produces suggestions or recommendations to assist the users in decision-making process. There's three different kind of recommender systems: collaborative filtering, content-based recommender systems, and hybrid recommender systems. Collaborative filtering recommender system is actually recommending me based on the decisions that other users that have similar taste like me has made. So using the information about other users. Content-based recommender system is recommending based on similarities of items. So if I have liked an item in the past and they have a new item that is very similar to that, it might be recommended to me. Hybrid recommender system is actually using multiple approaches together. Amazon would be a classical example of using recommender systems. Here, Amazon is recommending me books in different languages. I don't speak most of these languages. It's recommending me a book about knitting. I definitely don't do knitting. I used to do when I was young, but my shoulders can't take it. It's too much. After sitting by the computer the whole day, I can't do knitting. So actually, I would not buy any of these books. They are all something that is not interesting to me. And why is that? The reason is that Amazon doesn't know about me. Because whenever I buy something, I usually buy books. We don't have Amazon in Finland, so I don't use it for everyday things, but I buy books. But when I buy a book from Amazon, I don't do it myself. I ask my son to do it because he's so good with all this kind of ordering stuff. So he will order the books for me using his profile. So probably his profile is very interesting with all kind of Oracle books. But I have only used Amazon once when I was, well, actually twice. I have created my author profile in Amazon because my books are sold in Amazon as well. And I have once when I was in Tokyo, I have ordered shampoo and conditioner from Amazon Japan. And that's why it's so confused about me. So what is she really liking and what kind of person is she? Netflix is another example and actually didn't do so well either. They are very good with translations because this is proper Finnish, but the recommendations for me are actually not very useful because most of these that is recommended to me, I have already seen, either on television, on the plane when I've been traveling from one place to another, or I have seen them years ago in Netflix. Well, my husband says it's because I fall asleep when I watch something from Netflix. So they know that. And that's why they recommend me to watch it again, because I didn't see actually the whole show. I just saw the beginning and the end. But I doubt they are so smart. So I just think it's because they still don't have enough information about me. So they are trying to guess what to recommend to me. Well, these are quite interesting. I might watch these, but I have already seen them. So what's the point? So recommending is not easy. Another possible use case for deep learning would be visual recognition problems like computer vision, image classification, object recognition, object detection, image captioning, action classification, object image segmentation. Like here, we have a picture and a computer is finding things from this picture. So finding traffic lights, car, truck, person, even a handbag. So all kind of small, tiny little details it can find from the picture. So actually all kind of image recognition things or computer vision things are very interesting. And because I think it's very interesting, me and my husband, we decided that we will try it. This is some years ago already, we tried. So we have a house alarm system that is built using a Python. And we wanted to try some face recognition. So we have Raspberry Pis. I put the pen here so you can see how small everything is. So this is the old Raspberry Pi because this is quite old system already. And we had a camera. And we decided we will build a system that will recognize if somebody is at the door and will alarm us there's somebody at the door. Then we were thinking, why not ask the system immediately say there's 2 people at the door, or there's 3 people at the door. And of course, this will continue. Then we wanted to tell us who's at the door and so on and so on. But we didn't go that far at this point yet. So we found this wonderful web page, PyImage Search. If you are interested about anything to do with visual recognition or image recognition or anything to do with images, go to this web page because it's amazing. So we kind of copy pasted the code, edited tiny little bit. It was already pre-trained and everything, so we just started using it. The first test, we are sitting on the sofa in our living room. My husband is just starting the program. The camera is there by the television and it tells us 2 faces, which is true, there's 2 faces. Very interesting, not much work at all. So I have heard that it changes a lot if you add lights, you remove lights, you turn the face, you just have half the face. What if we change the circumstances and make it more difficult for the computer? What will happen? So I was thinking, I have a book of half of Trump's face. Will it recognize Trump or not? So let's see what happens. So instead of telling 2 faces or 3 faces, as my husband, me, and Trump, it also shows one more, the 4th face in our curtain, probably because of the lights. But a lot of smart people said it's probably a ghost in your house that your computer can recognize, even though you can't see it. So probably we have a ghost there. I don't know. But anyway, this was a very fun experience and experiment just with copy paste and a little bit of editing of Python code. So this kind of machine learning is not very difficult. So what if data is not available? The computer can create its own data. I have here an example. You can go and see it later. I will just, maybe I will show it very quickly, so how it works, if I can get it working here. So the idea here is that we have a car that should learn how to park. Okay, the idea is to find how to park a car without any kind of knowledge beforehand. So here we go. The car comes in. The red is the place where it should be parking is marked as red. It doesn't even know where to go. It's driving to the wrong direction. This is attempt 2, and so on and so on. So it's trying to learn how to park. It continues and continues and continues. It hits here, it hits there. It doesn't know where to go, and so on and so on. It takes quite many attempts. Every now and then it accidentally manages to park, but most of the times it's hitting something. This is 30,000 times of parking. Sometimes again, 50,000, it kind of finds the parking place, almost there. 310,000 attempts later, it's starting to be confident. So I am sure when you started to learn parking, it didn't take you so many times to learn how to park. It takes quite a long. So we will not see longer. You can check it later if you're interested. So it takes long because it doesn't have any knowledge beforehand. And there's no data available how to park. So it has to create its own data to be able to learn how to park. So what's the job I should be doing and what are the things I should not be doing? The thing it's doing is called reinforcement learning. So there's an agent, the car that we just saw here, that takes an action in the environment. The environment is our parking slot here. It takes an action, and based on the action, it ends to another state in a different position in this parking area, and it gets a reward, negative or positive. How well did it go? And based on these rewards, it learns. Again, this is not a silver bullet because defining the reward function is not easy. So should the reward come every 1 inch, or after it finally parks, or every 5 seconds? And should it be -1 and +1, or -1 and +10, Or what kind of reward should it be so it would learn to do the correct thing as fast as possible? So reinforcement learning is not that easy either. It is very good with games. AlphaGo, AlphaGo Zero. It was a very amazing moment when the computer was able to beat the best AlphaGo player, a human player. So that was kind of very interesting news for everybody. But is it good with everything else? So, because it needs a lot of try and error, it's learned so slow, much slower than humans. Is it something useful for other things as well? The good thing is that it will learn to be a perfect parker. It will be much better than I can ever teach to park. It will be much better parker. But do I really want to let it park and crash? Or can I build this kind of program that will allow it to learn? It's like a game, what we just saw. So can I build a game for the machine to learn? So that's a good question. What do we actually want from artificial intelligence? We want to have machines that can learn and think like a human, which is not easy because we don't know how we learn and how we think. Deep learning with reasoning, the common sense. So it has a common sense whenever making decisions. The ability to learn background information without attaching it to a particular task. So when learning to park on this parking area, it should be able to park in another parking area, but will it because that parking area has different circumstances? So to be curious and observation, to make observations. If it learns that grass is green, it should be able to know green in another context as well. So this color is green, I already know it. So like children, when you're teaching them, this is a dog, this is a dog, this is a lamp, this is a table, this is green, this is yellow. You keep repeating these things to children and they learn. They learn if the table is green and the wall is green, it's the same green. So it's not a different green, it's the same color green. So how do we teach that to computers? All we do is based on predictions. So we predict something because of the knowledge we have we already learned something and we are using that knowledge in our life, the predictions we know. This is one of my favorite videos. So the monkey was predicting that whatever the trainer put in the cup would of course be there when the trainer opens the cup, but it's not there. So the prediction was broken. And so much fun because predictions are predictions. And if they don't happen, it is strange. Jan de Kan has suggested a thing called self-supervised learning to be the next thing. So we would predict any part of the input from any other part, predict the future from the past, future from the recent past, past from the present, top from bottom. So prevent whatever is missing from the data you have and learn that way. So self-supervised learning might be the way to get computers that can learn better, even maybe close to the way that we learn. And the funny thing is that most of the times when we do this kind of research, we learn from ourselves as well. We learn how we learn when we are trying to figure it out for the computer. Maybe it could be self-supervised reinforcement learning, the next step. Who knows? It could be something very interesting. But whatever it is, machine learning is here today. It will be in the future as well. So it's definitely something that you should spend some time with, because first of all, it's really interesting, and secondly, it will guarantee your job because it will not go anywhere. Artificial intelligence and machine learning are here, and they will stay here in the future as well. But also, not just that, machine learning is very interesting, and it has so many interesting areas. It's not just about one thing, because machine learning is a team play with different skills put together. So you're probably and most likely the skill set you have is needed. Most of the thing we do in machine learning is preparing the data. That's probably something you have already done for years, because that's what we do when we play with data. So it's the same thing here. And then everything else on top of that. So it's really, really interesting. And besides, you can help your company by learning something new from the data and help them to make better business decisions based on whatever you learned from the data. So I just suggest you pick your area and start learning, because machine learning is so interesting and so full of all kinds of interesting things. I was thinking I speed up a bit because I know you all want to go and have your evening snack and go to bed. So just spoke a little bit faster, so we will have some time for the questions as well. I hope you learned something new here. And let's see if we have any questions.
Yeah, I will try to see if I have any question here. I have one, if you don't mind.
Mhm.
It's Rodrigo speaking. What was the coolest project that you saw machine learning working, like in a company or
My favorite one is my first project, of course, and that was a factory. So I was in a factory talking about something. Actually, I was talking about virtual machines, which is not related to this topic at all. So I was in a factory and meeting the manager and solving their problems with virtual machine. And suddenly I heard a big bang. I was like, what happened? I said, no, don't care about it. It's just one of the machines. It just went off, and I was like, is that serious? So yeah, well, not really. Nobody was hurt. I was like, yeah, but do you need to close your factory now because of that? He said, yes, we have to close it because we need to restart the machine again. And it takes about 1 hour to restart. So I said, you have a factory closed for an hour because of this incident. And he said, yes. And then I said, what's causing that? So why does the machine stop? And he said, we have no idea. Well, I said, how often does it happen? And he said, well, I can't remember, every now and then. I was like, okay. And I said, can I see the factory? It would be very interesting. So we went to the factory, and there's a lot of IoE everywhere. There's temperature, there's all kind of machines recording everything that happens in the factory. So they have all the data, what has happened in a factory. So we collected the data, and I said, can I keep this data and see if I can find anything from it? And he said, sure, go ahead. We have plenty of data. Just keep it and tell us if there's anything you find from there. And actually, yes, we did find from the data. We found out that when they open one door at the factory room, the temperature goes down a little bit and the machine breaks down because of this temperature change. And it was so amazing. It was a little bit difficult because it didn't happen exactly the same time, because the door was opened and then, let's say 5 seconds later or 10 seconds later, it happened. So it didn't happen exactly the same time. It would be held easy to find. It happened kind of first the door and a little bit later the machine. So that was super cool. And they were so excited when we actually found out this. And ever since the door was not open, they locked the door. So don't open the door. And that was the solution. So it can be any kind of problem that is solved with machine learning.
Very nice. We got 2 more questions. Can you let us know the learning path from DB admins to machine learn?
The learning path for DBAs is
what kind of books or
yeah, good question. Well, as I said, the biggest thing is the data, and that's something you already know. You know SQL, you know PL SQL probably. You have a lot of tools you can use for the data itself, because the data, first of all, we have to prepare it so that it's good quality. We don't like nulls. Nulls are confusing. We might need to be some normalization or standardization for the data and this kind of things, so that it's capable for the algorithm to process. So there's all kind of pre-processing for the data before we even put it further. So number one is preparing the data. So that's probably something that is very easy for somebody who's already working with databases. Well, the second question is what language to use. So how to move on from when you have prepared the data, because machine learning can be done with, let's say, every language, because most of the languages has libraries for machine learning, especially the basic algorithms that we use for those use cases I explained earlier. So depending what you want to use, if you want to stay with PL SQL, you can do that, because Oracle is offering for free Oracle Machine Learning for SQL, which is PL SQL packages in the database. You can use those to actually to pre-process the data, to build the model, to test the model, to evaluate it, to deploy it. So the whole thing you can do using PL SQL. Or you can use Python, which has the coolest libraries probably. Well, depending who you ask, somebody might say it's R, because R is the one that statisticians are using. So when they invent a new wonderful algorithm, it's first in R and then in Python. So depending who you ask, what is the best for who. But I would say that depending on your background, choose, and the company you work, choose the language. Because don't let the language choose you. So not that your friend says that R is the best, I'm going to use R. No, if your company is not using R, your company is using Python, then maybe Python. Or if you already know Python, why not to use it? Or if you already know R or Scala or whatever, you already know that language, maybe you should start with that, because there's so many other things to learn than a new language. So probably I would go with the language I already know at least a little bit.
Okay, we have one more question. Hallie, regarding predictions, how much we can really trust on the that machine will be accurate? Machine learning with AI can be fully trusted?
No, they cannot be trusted, because it's all about, well, already mentioned the data. So if the data is crappy, everything that comes out from the machine is crappy. So it starts already with the data. And the second thing is the algorithm and the hyperparameters. If the hyperparameters are wrong, the result is wrong. And there's a lot of discussions now in Twitter about bias. There's this example when there's a face that is transformed to a more visible face, and then back to a little bit dimmed face. And it's doing the transformation as a white man. So whatever the original picture is, it's transforming as a white man, because of the bias in the data, because it's trained with faces of just middle-aged white men. So that's all it knows. So it's doing all the transformation like that. So the bias in data, or the nulls in data, because null means nothing, or anything in the data that is not correct, will cause wrong predictions and wrong actions. And all the hyperparameters in the algorithm that are not correct will do the same. And also the fact is that when you have built the perfect model that will predict always correctly, something happens and breaks everything. Maybe you have more noise in the data, or you have different kind of data or whatever, and suddenly the perfect model doesn't work anymore. One classical example is a deep learning model that was very good in knowing if it's a dog or a wolf. So if the picture is of a dog or a wolf, you know, it's very difficult even for human eyes to know if it's a dog or a wolf. But this prediction was always correct. It always knew which one it is, until one picture came. And instead of saying that it is a dog, it's a dog, it says it's a wolf. And everybody can see it's a dog. So why is it saying it's a wolf? Because what the machine actually learned was the difference between grass and snow, not dog and wolf. So when something is on grass, it's a dog. When something is on snow, it's a wolf. And now we had a dog that was on snow, so it is a wolf. No, it's not a wolf. So we definitely cannot trust the machines to be accurate. In the best, machine learning is a wonderful guess, but it's never the truth. That's why we are needed. So we need to be there to see when things are going wrong. And first of all, that's why we have to evaluate the models very carefully. And secondly, when the model is in production, we have to follow the metrics and see how it's doing. And to be able to do that, we have to have metrics defined. So like accuracy must be 95% or 99 or 87 or whatever percent. And if the accuracy is going lower, we need to do something. At least we need to find out why, what went wrong. So when people say that machines will replace us, I will say definitely not, because we are needed there. They are still machines, and at least not yet. They don't have the knowledge we have, because they don't have this prediction power we have. We are predicting things like something in a cup is still there when we shake it, and if it's not there, it's a surprise. So no, machines and machine learning are not accurate, and they shouldn't be trusted blindly. Definitely not.
We have two more questions. Which path, in your opinion, is good, or it's better, Oracle machine learning or Python with its own libraries?
If you have Oracle background, I would probably start with Oracle machine learning. And there's many options with that. So you can use the autonomous database that has notebooks, and it works on the free tier as well. So you can just start with the free tier autonomous database and start using machine learning there. Or if you have it in your virtual machine, you have your database there, you might want to use SQL Developer that has a data miner add-on that you can just, it's a drag and drop tool where you don't have to program at all. You just drag and drop things and you'll build your model. But if you're already familiar with Python, that's not a bad option either, because Python is already, as you heard in the previous session, CX Oracle is a library to use data in Oracle database and code outside Oracle database. And Oracle is building a thing called OML for Py, which is Oracle Machine Learning for Python. So it will be Python code inside the database. They already have the data science cloud that also has Python available. So Python is a horse I would bet if I want to. Well, they also have R in Oracle database, but Python is something that both Microsoft and Oracle is obviously betting on. So if you want to take another language, I would probably take Python. And you could start now, like you just learned in Bruno's presentation, using CX Oracle and outside database, and then later on move that code inside Oracle database, and the same code should work there as well. So either of these two, depending on your background and what you want to learn.
Okay, I think we have just one more.
Okay.
Any tips with the best practice for structuring data lake to receive structured data and NoSQL?
I am biased on this question because I am a data vault person. So I believe in a data vault methodology, which has its own rules how to do that. So I'm not sure if you're familiar with how it works. So it has certain kind of structures that should be built, and it has a hash key that will join data to each other, including NoSQL, so and Hadoop and whatever is where you have your data stored. So using the hash keys, which is the primary key for all the data, you are able to actually combine different kind of data to each other. But my number one tip is when you store data, try to understand what you store. Actually, now we are talking about my thesis. So don't save data without understanding what you have, because if you store data and you don't know what you have, you will never use it. So when you are storing the data, you should understand what it is. Is it a recipe for a cake or is it a cat video? Because if you don't know which one it is, it's wasting space in your disk. So number one advice is understand what you are storing. And if you store different kind of data, like in this case, you will have structured data in a relational database and you will have semi-structured data in NoSQL, have some kind of way to understand what parts of them are the same. If you're using Oracle database, that's actually, well, depending what kind of NoSQL you're using. If you're using JSON, JSON has wonderful support in Oracle database, so I would not use NoSQL. I would put it in Oracle database as JSON. But if you're using a different kind of NoSQLs, if you by the way, if you're using Graph, I would also use Oracle database for that because it has very good Graph database as well. If you're using the other NoSQLs, by the way, NoSQL, I hate it. I hate the name NoSQL, and I hate the fact that it's actually an umbrella for so many different solutions. So it's just a weird concept in general. But what how we call is a semi-structured data. So somehow you have a structure for the data, and therefore you know this is related to the same customer. This information is related to the same customer as the information or the data we have in our database, our relational database. So have some kind of way to be able to join that data, to be understanding it's the same customer. So whatever the system is, how you do it. Data Vault has its own ways to do it. That's why I like it, so I don't have to think how to do it.
We have more questions. One is, what do you think about for the future? I mean, for using machine learning with quantum or something like that? Because what is the best language to learn for the future? Because Python and other language came from the previous that we are bits, and just that 0 and 1 is if and else. But for the future, what do you think that can be the next step?
Yeah, that is a good question, but I usually tackle that by saying that language is just a language. So if you know how to program, learning a new language is piece of cake. And I have actually proven that, because when I started doing my PhD, I had a professor who told me on Friday that he doesn't understand how I ever got my master's done without knowing Java. Because when I was doing my master's, everybody was doing Pascal. Java was maybe just invented or something, but nobody was using Java anyway. So he said, how did you get that? Because this has to be done using Java. That was Friday. I was like, who cares? So the whole weekend, actually the Friday evening and the whole weekend, I taught myself Java. I programmed the whole thing that was supposed to be done, and I actually even optimized it. And on Monday, I went to my professor and showed him, here you are, this is the Java program. It's doing everything you said, plus it's optimized. And he said, oh, I knew you can do it. You were just saying you don't know Java, but you know Java. I said, I didn't know on Friday, but I do now. So any language you will learn. But the skill of programming, you have to learn first. So how to do programming. So any language, for me, well, I'm a little bit biased here because for me, Python is kind of familiar and R is a little bit strange. It's like backwards to me. So if I'm okay to do R, but I kind of feel I'm doing everything backwards. And my friend who's from statistics, she loves R. She said it's the best language ever, and Python is crazy. So depending who you are, you feel different languages differently. So very hard to say who will win, but if you hear Oracle and Microsoft, probably Python will do well for the next years. Who knows?
Very nice.
Yeah. I like Python. And I saw the comment about knitting. I do like knitting, being honest, but I stopped knitting when I was about 20 something, because sitting the whole day by the computer and then knitting afterwards, it was really bad thing for my back and for my shoulders. So I was having headache every day. So that's why I stopped knitting. So actually Amazon was very, very right trying to recommend me knitting books. I have a lot of interest on the area, but I know I have my limitations.
We got one more question from YouTube channel. I think you already replied with the last question, but anyway, do we need to focus on using algorithms first, and we have to understand algorithm code?
When you start, I would say that you should understand what kind of problem you are solving. So what type of problem you are solving? Is it regression, or is it classification? Is it clustering? And then based on that selection, your language has some algorithms available for that type of problems. Then you try all those algorithms and see which of those is the best. At the point, you don't have to understand how they work. You just see which one is the one that suits your need. So depending what your metrics are. So what's important to you? Does it have to be very fast to learn? Does it have to be very accurate? Do you have to understand how it works? So there are different metrics that are important to you. So this algorithm, let's say you have 3 different algorithms available for, let's say, classification. So which one of these 3 is the best? And then you use that. Later on, when you are more familiar with machine learning, then go and find out how the algorithms work. I am so curious. I always want to know how it works. So I really want to know what's the difference between the 2 algorithms, but don't do it in the beginning, because there's already so much to learn. So just learn the big picture first. So how to do machine learning, how to get the predictions out, how to understand if the prediction is good or not, and so on and so on. And after that, go to details. But this answer was my answer, and my statistical friend would say, no, it's the opposite. Go to algorithms first and understand how they work, because I want to know the details before I do anything else. So again, depending on the person. But I would say no. Don't go to algorithm details in the beginning, unless you are a mathematician and you really love algorithms. Then it might be your way.
Okay, perfect. So I would like to thank you for the amazing presentation, Hallie, as always.
Thank you.
I saw some of your presentations before, and thank you for joining us today. Thank you for speaking on the LuxOUG. Also, I would extend my thanks to all previous speakers, Tom, Pete, Bruno, and all of our attendees today. Tomorrow we will have more lectures. Tomorrow, okay, I think Pete wants to say something. Let me see here. No? They wanted, no, okay, it's okay. And tomorrow we will have a full day of presentation, including Karen Agayev, Nikitas Shenakis, Frank Weber-Faust, and also Rodrigo Jorge. Okay, so see you guys tomorrow, and thank you for coming today to the LuxOUG Virtual Tech Days. Bye-bye.